Great. Well, welcome back for the second day of this little rollicking journey. A couple of people have said that they had thoughts over the night. I always like to start with questions, and you're making so many faces. I have to start with you. Oh, I can read on your.
No, I'm just reflecting on my project, right? So I don't know if you want to discuss it with everybody, but
Sure. I mean, the point of this whole conversation is to empower people to do more well in their operations, not to hear me speak. So if you've got things you want to share that are appropriate, there's time for the content.
okay, good.
Yeah.
No, so we're testing nutrient density with olives and almonds. So we have conventional and regenerative plots, and we're trialing, and we're doing it with IPB Bragança, which is a university at the north as well. So I was showing the project to Dan, and he says, you're not really doing nutrient density, you're doing nutrient variation. So the goal is to then collect more samples to understand where are we in our project, but also to define nutrient density for olives and almonds in this context. So I was thinking, how am I going to do that? What's the capacity for the lab? What's the capacity for everybody? How much is it going to cost? What's the logistics, you know? So I was trying to understand how is that feasible within the project?
Yeah.
And how we can create partnerships with different olive farmers and almond farmers or olive networks. I know you guys also have the azeite de ouro, oliveira de ouro, líquido ouro.
It's a project called Liquid for promotes the olive oil fields from this region.
Yeah, I know IARA also has an olive network of farmers. I don't know, I think there's some collaboration or thoughts that we can have here, like within different groups, to understand what we can do with olives and almonds. So this was my thinking.
You're thinking.
We were particularly wondering if there's already existing data on nutrient analysis of some olive farms in Portugal. So if you know any, please send them.
Yeah.
We as VividFarms, we try to establish a baseline of this available market about ongenine, polyphenols, antioxidants, total antioxidants, and vitamin E vitamin. And we are trying to make the baseline and to compare with our.
That's what you're doing. Those are compounds, all the compounds you're looking at.
Yeah.
So the thing is, you've got a decent amount of money, and you've got a lab that you're working with that sounds like you can send more samples to than you're sending. And what I was suggesting is, instead of doing, like, this is how a lot of research is done with sort of classic university research, is they'll do, one plot here, and then you change one thing and do it here, and you sort of say, what's the variation between these two things?
Yeah.
And when we've been determining what nutrient density is, our thought is, we want to capture a complete spectrum of the worst and the best and everything in the middle. The only way you can say what's 80 out of 100 and 40 out of 100 and 20 out of 100 is if you've identified what 1 and 100 are. And so what I was saying is, what's really most interesting to us is what are the outlier cases, right? Generally, when the universities are defining what is in a carrot or what's in a cucumber, they want to find the average and say, all cucumbers have this in them, based on the average. For us, the whole concept is there's a massive variation, and so until you can define that spectrum, you can't really begin to say, you may have variation between your regenerative and not regenerative plots, and it may be 2%, of this compound to that compound, but you have no idea what this, you don't have the context to know what that means, of how these regenerative practices are really affecting the full continuum. So you were saying you've got old olives and you're working, so yeah, it sounded like you have some budget, not necessarily a lot, but some budget. So if there's other people who have what they think are really good samples, like this is a really good, an amazing variety doing really well, that would be an amazing sample to add to their data set to provide context. But I think that's as far as we got last night.
Yeah.
So.
No, I think it's going to unroll into many conversations now
Yeah.
with everybody.
Yeah.
One question, how do you define the spectrum though? How do you get to the outliers, what you define as the number 1 and number 100?
So when I showed you the data yesterday,
See?
we just took 800 carrot samples.
Ah, okay.
We just got a really, really big data set,
Yeah,
and we got them from all over the US,
yeah.
all over Europe, organic, not organic, grocery stores, farms, farmers markets. Our question was, what is the spectrum of variation in the supply chain?
Yeah.
And you can't really do that except by going out and sampling as broadly as possible.
Okay, as
And-
broadly as possible. So this is the advice. So you sample as much as you can and then you define number 1 and number 100 with.
Based on what we find. And the whole idea is, we don't know if that's really 1 in 100. All we know is that's what we found is the highest and lowest. And so the concept of nutrient density, for my mind, is it's an iterative and evolving understanding based on deeper research going further and further. And if you have limited budget, which is what a lot of anybody I know who's in this world is dealing with, then you strategically want to be saying, I think these are some of the best samples I can find, and I think these are some of the worst samples I can find. What we really want to do is we want to define the edges, so we can say what's the scale of the continuum. It was 40x on the antioxidants and 20x on the polyphenols and 8x on the sulfur. You know, I mean, and then when we gone to the universities, they said it was 8% or 4%, because they had perhaps only sampled things that were uniformly bad. Great, most stuff is relatively poor. We get a bunch of relatively poor stuff. We say, look, the variation is not small. The variation major variation doesn't exist, because they didn't go and look to see at the spectrum. Yeah.
So what you're saying is you get this, you get a larger data set,
Yeah.
probably more, and then for like their study, you then see where the where their results lie within this set, because you're saying, okay, if there's a difference between the regenerative and conventional, okay, where does it lie within this whole variation? That's
What was the shift in practices? So for their study, the real question is, you got these intensive olive groves, and they've someone determined 5 things to do differently, and the question is, how much of a difference is that making?
yeah.
You don't know how much of a difference that makes unless you know what the full spectrum of difference is, right? And yeah, I mean, the thing is, this is all original research, because no one has looked in the space really to sort of characterize the variation that exists, and so it's just it's all a really open question. And I mean, by designing the studies the way we've designed them for the past few years, what we found is it sure looks like variation is completely massive, right? Like I said, those are the data for carrots, but we have that data for 20 other crops as well, and they all show that massive scale of variation. And if you look in the sort of like the literature, and you are look at this researcher in this country, this researcher in that country, and this crop in this decade, if you actually do like if say you mentioned you had AI and you could just ask AI to find like all the variations of this nutrient in this crop in all the literature everywhere on the planet, actually the variation we found is normal. But what most researchers are doing is this against this, or that against that. And so if everything's the same, the variety is the same, the soil's the same, the history of that soil is the same, it's just one management practice is different, yeah, maybe you'll only find a 2% difference or a 5% difference. But the fact is, there's all kinds of different soils that have been treated all kinds of different ways, all kinds of different varieties, different microbiome, history dynamics. And so what we really want to understand is what's the possibility for a crop, so we can know where the North Star is and where we sit right now. Yeah.
Well, also a bit out of the context, but connected to what you were saying yesterday, given that there is no homogeneous definition, neither in general for nutrient density, nor for each crop, what's the point to like begin with in order to define it? Can you explain that again?
What's the whole point? Why we're doing it?
Not the point of why, but like where can we start to begin defining it?
That's why I explained to you the beef project. And I said, once we identified that variation is massive in 25 different crops, every single crop we looked at, and the 8 elements and 3 compound families we looked at, we said we saw massive variation everywhere. Then we had to design a study to attempt to define what relative quality is. And that's why we're looking at over 100 compounds in the beef and over 200 species in the microbiome, and a full spectrum of genetics and ages and genders and management practices and soil types and, and feeding regimens. Only when we've ensured that, and human health trials, right? Only when we've ensured that we've captured what seems to be the kind of metadata that reasonable scientists would say are important factors and look for patterns, can we be able to see what the spectrum is. So that's why we're saying it's an expensive project. That's why we're saying it's $1 million a crop. Because to collect all that data actually requires a lot of lab work. And so what it sounds like you guys are doing is spending a lot of money on consultants to make recommendations. What we're doing basically is saying, every farm is a research farm. We're not telling anybody what to do. We're saying farmers do things differently in all kinds of areas. And so we're just gonna capture the dynamics on this farm, and 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 say in that case, we'll just say that we've got 350 different research plots. If you, I think it's called epidemiological sort of analysis or biological analysis, right? I mean, there's sort of the mechanistic shift one factor, and then there's I like to use the example of in Haiti, if there's a cholera outbreak, right? If you get people coming into the clinic with cholera, you ask them 50 questions, and you find the patterns. And basically, you'll find that, okay, everybody who's got cholera drank water from one of these 3 wells. This is the point where they come together. But you only find that by asking 50 questions. And when you find that, then you block the well, and then the cholera outbreak stops. So it's a form of, I think, legitimate, proven, accepted data collection and analysis, but it's very, very far outside of the way that most agronomic research is done. It's more of a biological, and biologists will do this sort of form of analysis.
Thinking like the next step, like how it's gonna affect human health, would also be then like kind of like a probably like redefinition of what are the quantities that are actually healthy for us coming from those foods.
That's why we had in our beef project, we're a feeding trial for humans as part of it.
Oh, okay.
And so we're doing that. We're feeding this beef to humans for this week, and the other beef to humans for that week. And then we said the fake beef to them on the 3rd week. And we're not doing long-term feeding trials, but we're looking at the inflammation markers and saying, how is this affecting inflammation in their blood and their urine? And we generally understand that inflammation is not a good thing. And so if this beef is anti-inflammatory and this beef is pro-inflammatory, we can say that's an important data point to integrate into our definition. But yeah, I mean, I think the concept, people get the concept really rapidly. Oh, some's good, some's bad. If it's true that you can flash a light and see good and bad, oh my God, that's amazing. But then how do you define it is a really big question. And I haven't found many collaborators who have the capacity to engage at the scale of comprehensive systemic analysis. It's been much more people doing side-by-side trials, which is great, but that's just, you do this and do this, and you're just testing nutrient variation between this trial and that trial. I wouldn't call that nutrient density research. But who am I to define the term? Just because I used it first doesn't mean I had to define it. It only gets defined when we together coalesce as a broad community around a definition. Yeah, so.
Practical question, in terms of like how to aggregate, because one thing is to get the nutritional profiles and to say that's the lowest and that's the highest. The other thing is to aggregate them with all the data of practices, soil, weather, kind of, how hard it is to do that in terms of like people, knowledge, like machines or?
So our protocol was, the first thing, we basically as an organization effectively spun off about 5 different companies. We've been like I think it's called like a venture studio or something like that, because we're like, oh, we need a big open data framework where all this information can be captured, people can maintain their data integrity, autonomy, they get to own it and nobody else gets access to it. It should be interoperable, et cetera, et cetera. So we had to basically find a group that was willing to build it all out for us. raise the money, hire them. They started a company. If anybody's heard of Open Team or FarmOS or Survey Stack, there's a bunch of these software systems that are basically are, you know, I mean, the Open Team got funded with a $5 million match by the USDA, and Survey Stack is a software that they're using, which we basically helped establish. So there's a whole bunch of logistics behind the scenes of building the data set out to facilitate it and have the surveys. So yeah, I mean, we didn't do a bunch of in-season monitoring because that was outside of what we considered was a priority as far as our budget's concerned. So whenever anybody sent in samples, part of the complete sample was answering this questionnaire. And so we just identified 50 questions that we thought were relevant. Many millions of dollars could easily be spent on this. The question is, what's the baseline? How do we establish a baseline? And then hopefully engage more legitimate professors and universities and governmental agencies to deepen this research over time, both with human health trials and monitoring, et cetera. I mean, there's an amazing opportunity here to deepen, for lots of research to be done for many, many decades. But until you have the initial papers published that show there's something interesting here, you can't get the governmental agencies to write the RFPs for the researchers to go look more deeply into these topics. So the first thing to do is to establish a paper trail of peer-reviewed papers that actually shows this is an interesting topic. So that's where we're at right now, is strategically trying to create that you know, framework. Yeah.
Good morning.
Good morning. Welcome.
My question here is, I have the profile of the nutrients, but do I analyze the same nutrients for any product, or is there a profile that is specific for a crop or a product?
Yeah.
And how do I somehow aggregate, or is there an algorithm that is going to put all these data together in order to have the nutrient density of the product?
This is exactly the question. Yeah, so, I mean, what we did with the beef project was we went and found people that were researching, that had a lot of experience researching beef and looking at cows that were fed grain and cows that were fed grass, and who had some experience with what the nutrients were that varied in those animals. And apparently the amino acids don't change. Amino acids are in meat and animal products are like, there's a homeostasis that the body maintains regardless, and so those are not nutrients that vary. But fatty acids change massively. And the polyphenols change massively. And certain elements don't seem to vary at all, but certain vitamins do. And so you start out by going to the researchers in any given field who actually have access to the data, and they can say, these are the things that actually seem to shift in this crop. And then you prioritize those compounds and nutrients as the ones you begin to look at. But yeah, but then if you're doing real science, proper science, even if you agree that these are the compounds that we're looking at, you have different extracting agents, you have different, lab machinery, and so the kind of variation that you get based on just the different labs, even using the same extracting agents, and they're using different pieces of equipment, is significant. This is one of the things that took us so long in the beef project was, like, there's 8 different ways to measure these compounds. And if you use this one extracting agent, these 3 things come out really easily, and those 3 things disappear. And so how do you efficiently, what are the extracting agents that you can use at which concentrations to get all the compounds to come out in one run that you're looking for at numbers that you think are trustworthy? When it comes down to it, the actual, reality of labs and the ability to get real numbers, like quantitative numbers, it's Wild West. It's completely the Wild West out there. I mean, this is like one of the big secrets under the table. Like, the emperor is not wearing many clothes. Like, the numbers you get when you actually get down into the weeds with these labs and with these machines, it really does vary to a dramatic degree. And I mean, Stefan Mavlit, who's our PI at Utah State with the beef project, I mean, he's been tearing his hair out. We've been working for years and trying to figure out, like, he's been publishing new methods because this really is original research. How do you pull out these vitamin spectrum, like B12? I was just talking to him a couple days ago, all the B vitamins. He can get B1 through 6 out in one run and 12, but all the other Bs, they're not there. And we're still trying to figure out how to get the B vitamins out of the beef in one run. And it's like, it's literally cutting edge, original research. We're publishing the methods right now. So we're right up against the edge of like what science can do, which is kind of, I don't know if that's exciting or depressing or what exactly it is. But you know, we kind of have this idea that we can know things, so we can know numbers, and numbers are a real thing, and we can find them, and that can give us confidence about what reality is. It's an open question. I mean, the real open question is it the compounds that matter? You know, I mean, or is it the coherence, the vibrational coherence? Anybody know about, you know, chromatography and biodynamics and vibration and harmonics, and like if 98% of the compounds in your body are water, right? You're 75% water by volume, but water molecules are small and protein molecules are large. I think 98% of the molecules in your body are water. Like, we are basically vibrating liquid crystals of doped with a couple different compounds. And so, is it the vibration of the food? Is it the vibrational coherence of the food that matters? Is it the chemistry of the food that matters? In the French literature, you know, with redox potential and stuff like that, they're only looking at the vibration of the plant to determine plant health. And they're looking at pest and disease resistance, and when your pH is here and your OH is here, bam, that guarantees insect susceptibility. And when your pH is here and OH is there, that guarantees fungal susceptibility. They're not looking at any compounds. They're looking at the vibrational resonance of the plant, and they can predict with 100% confidence susceptibility to infestation and disease, not by looking at any compounds. So what is the nature of you know, substance? What actually matters? I mean, chromatography, right, in biodynamics, like, you might not get a high level of nutrients, but you get this beautiful vibrational structure. I mean, we're basically framing it as nutrients, and like, now everybody's talking about nutrients, but like, we could be totally off in the wrong direction. What actually is vitality? What is life force? What is vibration? What is nutrition? What causes you to be healthy? Is it the compounds? I mean, as far as I'm concerned, these are all open questions. So, yeah, do you want to get even further down the rabbit hole? That one? You thought it was complex already. No.
Let's keep on nutrients.
Well, that's the thing. Like, I've been talking. My true like vision when I started this whole thing was coherence. I wanted a coherence meter. I wanted to be able to test the vibrational coherence of a food because I thought that's what mattered. I thought it had to do with vibration. From everything I know, I'm pretty sure that's actually an important thing, which is why I don't like microwaves. Because you put something in a microwave and, you know, it's like, it's warm, but what you did to those water molecules was completely fry them. Right? So,
Okay.
I don't know.
But if it is the compound?
Yeah, if it is the compound. Good. We have to be open, proper scientists, and it's, we're really questioning everything, all of our assumptions, right? Yeah.
This means that we have a group of compounds that we are profile of compounds, a list of compounds.
Yep, exactly.
That
Yes,
we
yes,
are
yes.
going to analyze. For
Yep.
carrots, that is different
Than cucumbers.
For beef or for
Wheat.
For beef is
Yep.
logical, but for wheat, for
Yeah.
beef, and then I will look at the profile of each compound in this variation limits or
Yeah.
range, and then somehow I aggregate these data
Yeah.
Or I just pick some to.
Right. So how do we do it? So this is so what I was saying. So right now we're opening up this bionutrient definition standards board, and we're saying now we have a massive pile of biochemistry data of the nutrients in the beef. We're not the ones to decide what's good and bad. We're a small nonprofit educational organization. I think Shauna has her master's in agronomy. I've got a BA in history. Like, we are not the ones who should be determining what quality is, right? So we want credentialed professionals in the space who understand biochemistry to be able to look at this data and say, we think the biochemistry in this steak is the best of all the ones we can see, and this is the worst, and the rest of these we'll scale them like this. And then we want to hand the microbiome data to the microbiologists and say, you guys know microbiomes, like really, you know about this kind of stuff. You know about diversity, you know about which families are symptomatic of which kind of dynamics. Please, will you give us guidance about which microbiome looks best and worst and scale the rest? And with the agronomists and with the nutritionists. That was what I said yesterday, but it bears repeating. The strategy here, from our perspective, is we raise the money, we design the study to look at all these things in context, then we provide that information to people who have the knowledge to make educated statements. When the microbiologists have laid out their 1 to 100 scale, or best and worst, and the biochemists have laid out theirs, and the agronomists have laid out theirs, then we bring them all back to each other. And we hope, but we don't know yet, that the ones that the biochemists said are best came from the animals that the microbiologists said were healthiest, that caused the human health response that the nutritionists said was best. Only when we actually know that these compounds correlate with this animal welfare, correlate with this human health benefit, correlate with this ecological benefit, do we have the data to confirm this One Health thesis, right? We're operating with this One Health thesis, that soil health, environmental health, animal health, and human health are the same thing. But the way to go about developing that would be to actually collect the data, engage the specialists, look for the patterns. So this is our hypothesis that this is true. And if it is true, we hope that we'll be able to find 5 biomarkers or something. And this is why I said yesterday, perhaps the omega-3, omega-6 ratio will be one of those compounds, one of those biomarkers that correlates, and maybe the B12, and maybe the polyphenols, maybe the antioxidants. We don't know what those compounds are, but the vision is, after the credentialed scientists get done making their scale of 1 to 100, and we're able to feed that back into a big data statistical, what would you call it? You're a statistician. Principal component analysis thing, whatever that is. We'll find patterns, and we'll be able to pull out biomarkers, and then we can go to anybody who wants to build a meter and say, anybody who wants to build a meter to test nutrient density in beef, from our understanding, these are the compounds at these concentrations that correlate with good and bad. And if you make that meter and sell it, we'll tell the whole world that they should buy your meter because it tests quality in beef. And then repeat with wheat, and then repeat with milk, and then repeat with olives, and then repeat with almonds, and repeat with apples. That's the strategy for defining nutrient density. It's a bit of work. But all things considered, it is a big job, right? But actually somebody's willing to step in, which is great. I'm like, you guys want to be part of the project with us? Because we're running around here by ourselves. So come on. Let's get a team. Let's get a team together. Let's build a coalition. Let's develop partnerships. I was in the Netherlands last week, right? And there's a bunch of EU calls. There's a bunch of EU calls out there for money, it seems. I don't know if it's the Horizon grants or which grants there are, but it seems like there's some opportunities here in the EU to get governmental money that can be developed in partnership with research universities, right? I mean, in Italy and Sweden and Portugal and wherever. And there are people who know a lot about wheat. There's people, I was in Italy meeting with these researchers in Bologna, and they were looking at the nutrient variations in wheat, and they're like, these are the compounds, and it sure looks like, I got a whole notebook full of like, she's like, we know the compounds that matter. We know the compounds that vary in wheat. Great. And we know that people at the University of Florence who've been studying human health response and seeing, you know, it's not gluten, by the way, because gluten is in all wheat, right? It's the shape of the gluten or the type of the gluten, right? The modern wheats just have a gluten that, right? Did we know about this? I didn't know anything about how the modern wheats were bred. So basically the gluten is more like complex, less digestible, and what happens is it can hold more air bubbles. It's like bubble gum, like some gum, like you blow it and doesn't hold a bubble, and some bubble gum, like you can make a big bubble with. So they selected the wheat so that it could hold more air bubbles, so that you needed less actual wheat to make a loaf of bread. The fact of what makes a loaf of bread big and light and airy is what makes the grain indigestible. Did anyone know that?
No.
The heavy brown bread that doesn't hold much air is digestible. The wheat that makes the bread big and light is what makes it indigestible. That's the chemistry. I didn't know that. It's so exciting. When you go and you talk to these researchers who are down the rabbit hole, they know so much already, right? There are all these researchers who've been figuring all this stuff out, and there's a whole group here in Florence that's been doing stuff for 30, 40, 50 years. And there's a different group over here in Bologna doing all this amazing stuff. But they aren't necessarily coordinating with each other, and sure as hell, there's no activists and social movement going to them and integrating their insights and putting it into a comprehensive framework that consumers can have access to empower themselves. So it's really this amazing opportunity to take advantage of all this brilliant work that's been done and integrate it. You know, it's been siloed, right? This whole thing about reductionist, you know, mechanistic, colonized paradigm. I think of it as the soil's been tilled, right? You've got that beautiful mycelial web, and when you till the soil, that web is shredded. And the first thing that comes back is the bacteria, right? You got a little bacterial colony over here, got a little bacterial colony over here, a little bacterial colony over there. That's what these siloed research groups are. There's a little bacterial colony with putting some information together, and another little bacterial colony putting information together over here. And then, if they aren't disturbed for too long, along comes a mycelial hyphae, and it connects those two bacterial colonies, and all of a sudden, they begin to engage in symbiosis. That's the opportunity here, is to take these nodes of insight and wisdom and perspective and web them together. So, yeah, it's a project. But, you know, I think we talked yesterday about the implications and opportunities. If we can do this science and we can integrate it well, and we can feed that back into agronomy and connect it to consumers, we can disrupt agriculture honorably with integrity, and we can use economic incentive to, you know, accomplish the regenerative vision that so many of us, I think, deeply hold as a vision. So, but that's the process. Yeah, thank you for asking these questions and giving me a chance to sort of elucidate it more deeply. Yeah.
Yeah, I've been hearing for this for some time. There's an organization in France called the Blue Blanc Corps.
Yeah.
Apparently they've been doing probably on a niche because it's only animal products and on only France-wide scale, but apparently they've been doing for the last 20 years an incredible job of connecting consumers with agricultural practices and the quality of the you heard about them probably. No?
So they were the host of our lab in France.
Right.
Our European lab that we started in 2020 was in partnership with Blue Blanc Corps.
Right. And how is the reach of what they're doing in your opinion?
So yeah, I mean, Pierre Biel is the sort of the founder of the organization. As far as a structure for a certification, it's brilliant because they've got a membership base which includes researchers, it includes companies, it includes government, you know, representatives, it includes farmers, it includes consumers, it includes chefs. It's brilliant structure. So the farmers have like 30% of the vote on the board, and the consumers have 20% of the vote, and the chefs have 10% of the vote, and the governmental agents have 10%, and the researchers have 20%. And all these different constituencies You can join as a farmer, and your membership cost is 50 euros, and you can join as a company, and your membership cost is 1,000 euros. But they've been collecting this data, and they've been doing it for decades. I mean, they've been doing all kinds of human health trials, right? Like, it's so exciting. I mean, what they did was they would feed these cows and pigs and chickens a more balanced diet, and these cows and pigs and chickens were just fed whatever normally was being fed the animals, and they would do human health trials. They said, don't change your breakfast of bacon and eggs and cream in your coffee, just eat this bacon and eggs and cream. And they were looking at inflammation in people's blood, and they were able to see inflammation drop like through the floor. Like in 4 weeks, by not changing your diet, just changing the source of your diet from animals that were fed a more balanced diet, like the inflammation, which is the cause of chronic disease, disappeared in people's blood. And they did this with normal people, then they did it with pregnant mothers, and then they did it with old people, then they did it with babies. And they've done it with all kinds of different people at all different life phases, and they've seen it happen across the board. So they've developed a certification label, which is the only certification label that I'm aware of on the entire planet that has to do with nutrient variation. It has to do specifically with omega-3, omega-6 ratio. Their products are sold in 9 or 10 countries at least, a number of countries in Europe, Japan. I think there are a couple products in the US. It's over 2 billion euros a year in sales of products with their label on it. So it's not a small thing.
So we have a framework that works already.
It's a brilliant structure.
Because often what I see in Europe, at least, is people are always waiting for the next big funding from EU.
Yeah.
And from and there's actually organizations doing this a bit under the radar.
Not in France.
Self-organizing in
The
France.
French refuse to speak French to anybody else. If
Yeah,
you come to their
that's the
country,
thing,
you gotta
right?
speak French to them. But they're doing something really exciting,
But
right?
it's super exciting, you know.
But so the thing is, it's a binary. It's either you have this ratio or you don't, right? So you either are certified or not certified. And my concept here is that there's a 1 to 100 scale. I think it's a great step in the process. Maybe the 1 to 100 scale is not necessary. Yeah. As far as a model, like a living model of a step forward that's beyond anything else that's out there, I think what Blue Blancourt is doing is completely, everyone in the world should know about it. And especially the way they structure the organization. Because it's designed to be this bottom-up, different constituencies have votes and have, vetoes and things like that. And it's really been very, very thoughtfully designed as a way for it to be owned and governed and collectively led.
And
Yeah.
who's behind it? Who was the...
Pierre Viel is his name.
Yeah.
W-I-E-L-L or E-I, I never get it right. He's a wonderful man.
With a
Viel.
W, right?
It's said V, but it's spelled with a W.
Yeah.
Yeah, Pierre Viel.
I think John Kenneth interviewed him at some point.
I introduced them to each
All
other.
right, okay.
Yeah. No, I've been telling everyone I can about Pierre for 5 or 6 years.
Yeah. And then
Yeah, he's amazing. He's made brilliant work, 100% brilliant work. The French, I mean, they're full of themselves in many cases for good reason,
That's
They're-
what I was saying the other
The
day.
problem is they're onto some stuff. They're onto the physics thing, and nobody else I know of is talking physics. They're looking at vibration, they're not looking at chemistry.
Redox.
Exactly. 100%. Olivier Husson.
Yeah.
Olivier, I again introduced Olivier to John, right? I mean, I met these guys at a conference in 2019 when I was in Paris speaking. Maybe it was 2018, I can't remember. But when I came to their conference, I'm like, my God, you guys are just way the hell ahead of us. Like, we have so much to learn from you. But there's the Anglophone world, right? The
Yeah.
people who speak English. There's the Francophone world, the people who speak French. There's the Germanic, I was telling you about this guy, what's his name?
SRI also is from France.
Of the SRI, exactly. It was a French, 100%. And Olivier knows the guy who started SRI
Yeah.
in person. Yeah. No, we have all these different cultural, it's like, again, it's Tower of Babel, right? There's all these different cultural groups language groups, whatever it is, that have their wisdom. And if we can figure out a way to translate between our cultures, and we can take the insights from the German-speaking people, and take the insights from the Latin-speaking people, and take the insights from the, Hindi-speaking people. Right? You were talking about what were they? The people from
The Kogi.
the Kogi? Yeah.
From Colombia.
I mean, I don't know, like that should be something that we could all learn from. Yeah, right? There's all these perspectives. And in many cases, we have our little circle of what we've heard of, and that's the only world we've been exposed to. We were talking about politics, right? And why it is that Americans don't have any context about all the horrible things that have been done by America around the planet. Like, because they just watch the American media, and the American media doesn't talk about it, right? The Americans don't know that we've killed 20 million people since World War II around the planet. We don't know. We literally don't know the tens of millions of people that we have killed. Like, because we're not told about it. It doesn't make it not true. It's just that we haven't been exposed to the context. So the opportunity here is for us to cross-pollinate, share and learn from each other, use science as a lingua franca, use science as that open framework for common sharing and learning. That's the value of science, as I understand it. That's the principle of the Enlightenment. Like, the value of the Enlightenment is to use science as this framework for common, universal discernment. And just because I'm organic, if the data's telling me organic's not great, I got to deal with that, right? That's the point of science, is you got to deal with it, even if it makes you feel uncomfortable. All right. There we go. Got me going here on a bit of a rant. Yes. One last question. That's it. Then we're done for the day. All right, good. Whew. Break time.
Going back to the nutrients
Yes.
and calibration and everything.
Yeah.
Have you considered doing, like, because you're limited a bit by collecting data through the optical spectrometer, no? Because I understand that your concept is that eventually, in that part, not to have the consumer part, but have you considered doing mass spectrometry analysis of like a proteomic, like a kind of like more global analysis of the.
That's how we've been doing.
All of it, what's in there?
All of our lab work is mass spec, ICP, is a GC, LC. We're only getting 100 compounds in the beef from a GC and LC and ICP.
Okay.
We're not getting it with a handheld.
Yeah, that's what that was.
No.
Okay.
Right? Anybody knows what GC and LC and ICP is? That's what we're using to do all of the raw data collection. And then we're flashing a light at it with a meter, and we're seeing if we can find patterns using your LCA. I got a BA in history, and I'm really happy with my BA in history. I don't need any of this science stuff. All you people who good, I'm happy to raise money and pay you, because I don't want to do that stuff. Yeah. All right. Shall we engage some of the questions on the board? Are there more questions you'd like to work with, or should we get to the handout? Anybody have a preference? Yes.
The compost.
Compost.
Yeah.
Yes.
In the last day, you talk. Sorry, my English, but I try.
No.
You talk it's not necessary compost. What you're using.
Yeah.
I'm using for the beginning, not to continue, but the starter of the system.
Mm-hmm.
For the balance of the soil.
Yeah.
You preferencing compost or nothing compost?
So what are my thoughts on compost? Because when you talked to me this morning, what you said was that I said that I don't like compost, or I'm against compost. I did not want to leave people with that impression. So I said, please ask me this in front of everyone so we can have a bit more of a conversation about it.
Yes.
I think one of the things I said was, the basic model for me is, the basic question should always be, what does nature do? Right? The first question is not what you've been taught, not what the certifying agency said, not what this professor told you, not what this book said. Even if there's 50 books that all say the same thing, the first question is, what does nature do? And then if you get disagreement between what nature does and what the books say, my proposition is, nature's been doing it for 400 million years. The books have been published for 50 years. I'm going to go with the one that's been around for 400 million years. So when I was talking about compost, I said, where in nature do you see a bunch of different organic matter taken from different spots, brought to one spot, piled up, turned over numerous times, and then spread out on the land? Because that's not what I see nature doing. What I see nature doing is dropping dead plant material with maybe some pee and maybe some poop and the very occasional dead body on the land or tree, And that's slowly being digested in situ. So you can call that composting if you want. You can call that cold composting, because that's really functionally what's occurring. And that's what I found to work very well on my farm, is to lay lots of dead organic material on the land. I call it mulching. When we were walking around this farm a couple days ago, and we were looking at the soils, and we were looking at the area where the compost had been put down in good levels and the liquid fish had been put down. And then over here, we were looking at the area where there basically had been some straw put down. Over here, where the straw was put down, there were big earthworms. There was all kinds of, millipedes and centipedes, and just like all kinds of life under a very thin layer of mulch. Tons and tons of life, good structure. And over here, where the compost was put down, it was tight. Didn't quite smell right. Things weren't growing that well. There was no earthworms. And so a lot of us have been taught to use compost. And just because we've been taught it doesn't make it right. So is there a time and place for all these things? I think absolutely. Was I talking about the animals? And I don't think I was talking about the confinement. I don't think I was in this group, not yesterday at least. At various points in time when I've been in other parts of Europe, there's this thing called slurry, which is a big issue, right? Because we've got cows in Ireland or England or wherever they have, the cows have to go in for the winter because it rains all winter and the soil is constantly wet, and if the cows were outside anywhere, they would just be turning it into a complete mud pit. And so they basically bring them in for the winter, and instead of doing what they used to do in the olden days, which was lay down layers of, we call them ferns, they call them bracken there, and other sort of organic material that would make what we call a bedded pack. They've been inspired by the government to take $1 million loans to dig holes underneath the barns where they basically put all this manure and urine in these big massive tanks, and then they take that liquid and they put it in a big thing in the back of the tractor and they go and spray it on the land every spring. And it washes off into the rivers, and the rivers are full of high levels of nitrogen and phosphorus. The earthworms all die, right? As soon as they spray that slurry on the land, all the earthworms come up and die. It's very, very high conductivity. It pollutes the aquifers. There's all these stories about how cows are bad for the environment, and now the government's saying you can't have cows because they're bad for the environment, because they've been doing this thing, which is taking the manure. In the olden days, they didn't have these holes in the ground. In the olden days, they had bedding. They had the straw from the oats that they raised to feed the horses, right? So they had this basic organic matter, and the animals pooped on it and peed on it, and when it got dirty, they put more down. So that would be an example of a beautiful opportunity to make compost in my mind. Like, you've got all this animal manure. It's not appropriate for those animals to be running around outside. You want to take a pile of that and build it up slowly and layer in the different organic material you can source from your land. I would throw my rock minerals in there if I was taking soil tests, because whenever you put your minerals into a compost pile, they become much more bioavailable. So your gypsum, your rock phosphate, your copper sulfate, your sodium borate, all that stuff, if it goes through a compost pile, gets pre-digested, it becomes more bioavailable, so you need less of it. So anybody who's operating on scale, you got 100 hectares or 500 hectares, and you can't afford to buy 15 pounds of sodium borate per acre, but you can afford to buy 3. This would be a great way to mix it into the pile. Like what the farmers do where I'm from, where it gets cold in the winter and we have to bring our cows in because there's 3 feet of snow on the ground. It's not because it's raining all the time and the ground is mucky, it's because there's just, it's hip deep. And they've got the barns that have tall sides, and they just bring in the organic matter every day, lay it down as bedding. And then when the cows go out, they take all that and they make a big pile and they let it sit there for a year. And then they go and spread that out with a spreader onto the field as a product. Like, that to me is a practical and appropriate use of compost, because you've got a waste product as part of your cycle that you want to be getting out there. But to go out and to be feeling like you have to be adding layers of inches of compost every planting cycle. There's a bunch of people that are writing books and giving online courses that are saying, like, you need 10 tons of compost to the acre or 50 tons of compost to the acre. And the farmers who are doing market gardening are being trained to use these massive quantities of compost that's coming from who knows where. That I think I said yesterday, for me the model is, how can we practically empower smallholders in the developing world? What are the techniques that we can provide that are completely viable from an economic standpoint for those smallholders in Mali and Karnataka and Zimbabwe? Like, it's not plausible to add 10 tons of compost per acre or 50 tons of compost per acre in those ecosystems. That's not a practical scenario. So what is nature's pathway? Nature's pathway is you grow plants, and after they grow, they fall down and they compost. And then someone was asking about earthworms and how you get earthworms into the soil. Maybe it was one of the questions up here. I'm not sure whose question it was.
Yeah.
In your question, in my experience, my earthworms show up when there's a nice layer of mulch on the ground. We saw that out here when we went for a walk out here a couple days ago. Where the compost had been put down, there was no earthworms. Where the mulch had been put down, there was lots of earthworms. That act of just giving nature the stuff to then digest into the soil and to make the topsoil in situ is less work for you. It's how nature evolved things to work. And so as far as significant applications of material on the land, from my perspective as a farmer, the thing I spend most money on is hay. That's the thing I bring in, is that mulch. It keeps the weeds down, it feeds the soil life. I mean, I've got 4 acres that I could make hay out of, but I don't have a tractor with a mower and a baler, and so I don't. But yeah, as far as using compost as an inoculant, people know about the Johnson-Su compost. People heard about the Johnson-Su bioreactors, which is basically a static compost. You don't turn it, you let it sit. You put woody materials into it, which means it has more of a fungal dominance. You know about the idea of when you turn a compost pile, effectively you're engaging in tillage, right? You're shredding the microbiome. What causes the heat to increase after you turn a compost pile is the high level of bacterial activity. So when you turn compost, every time you turn compost, you're killing off the fungi and accentuating the bacteria. I don't think we've talked about the bacterial fungal dynamics yet in this course. This is, I think we get people.
Fungal disease is not a disease.
What's that?
No, sorry. Fungal disease is the no.
I'm talking about, so basically there's an evolutionary continuum in soil from disturbed to climax forest, right? So the microbiome of a disturbed soil is highly bacterial. The microbiome of a climax forest is highly fungal. There's a continuum between lots of bacteria to lots of fungi, and there's different plants that prefer different microbiomes. Like a cow has a different microbiome from a chicken, and a chicken has a different microbiome from a rabbit. Pigweed has a different microbiome from an onion has a different microbiome from an apple tree. So most of the plants we call crops prefer a relatively balanced annual crops. Sorry, most of the things we call annual crops prefer this is a Johnson-Su here. Yeah, right. So this has gotten famous. David Johnson and his wife have been traveling around the world and giving courses to basically make this thing where, I mean, it's a decent amount of work, but it's a stable, you just put it in and you let it sit for at least 12 months. You don't disturb it. So when the pile is done composting, it's got a much more balanced spectrum of microbes in it. I would call that more of an inoculant. I mean, the research they've been doing in New Mexico and California, et cetera, they've been putting it down at 2 pounds to the acre or 3 pounds to the acre. Right? Instead of 10 tons or 30 tons, it's 2 pounds or 3 pounds per acre. That would be 1 kilogram or 2 kilograms. We'll call it 3 kilograms per hectare. Right, so 3 kilograms per hectare is not compost used as a NPK supplement. It's compost used as an inoculant. And so the great results they've been getting with that has to do with the soils they've been you know, the research that David Johnson did at New Mexico State University that blew his mind was in cotton fields that had had horrible amounts of chemicals applied for decades. And when they put this compost down at 2 or 3 pounds per acre, what they were doing was reestablishing the microbiome, right? They were re-inoculating the soil with a broad spectrum of microbes. And when those microbes were present and they put the cotton seeds in, they did a lot better. They didn't do a lot better because there was X pounds of nitrogen or phosphorus applied. They did much better because they had healthy gut flora, which we talked about yesterday. So
Be applied a large scale,
that's what they're doing on large scale.
3 kilos per hectare, you said.
At that ballpark of a quantity. It's an inoculant. We haven't talked about inoculants yet as part of this course. We'll talk about them today. As we talked about the principle of when a baby's born, it gets the colostrum and that establishes gut flora. So establishing, I said if there's one thing you should do, of all the things you should do, it's give your babies their colostrum. All right, we got some conversations going here.
So if we will continue.
What's that?
If we will continue speaking about this.
Yeah.
So if I am a conventional farmer, right,
Mhm.
and I am like in an area which is sandy soil, really,
Mhm.
basically, and I have vegetables,
Yeah.
and I would like to convert to regenerative because I found or I was inspired. So I would like to make a change.
Mm-hmm.
So how I should approach that? Because I have low organic matter, practically none.
Yeah.
Then I have high bacterial dominated soils. I have low nutrients because
Yeah.
I have no holding capacity in the soil. And I am in dry area where doesn't let's say rain for 4 months.
Mm-hmm.
So how I should approach to make the change?
Can I finish this topic of microbes, microbiome and inoculation first, and then maybe some case studies would be a great way to engage?
Very practically to put this everything
The next
together.
slide on our handout has to do with inoculation. So if that's what we're just naturally evolving to in the conversation, then we can just go to the handout, and I can cover that topic in the more systemic fashion I like to cover it. So I think like I said, I mentioned this concept of colostrum yesterday. I said, what I conveyed that is in the form of humans. You understood the concept. I said, and I'll say it again, if there's one thing that you take home from this course, and you do, if you asked me, Dan, what of all the things you're going to tell me in this 24-hour ramble that you do, if there's one thing I can take home and do, what would you suggest it be? What I would tell you is inoculate your seed. It's the least expensive, least effortful, most powerfully beneficial thing you can possibly do of all the things you can do. From my perspective, with everything that I know, what I'm going to say is ensure a full spectrum of species are present on that seed as it germinates. Make sure your babies get their colostrum. That is going to be the most powerful thing you can do to support the system in flourishing. So then the question is how? What? How do you do it? What is an inoculant? I'll tell you what I do, and that is that I have a friend who, name some of you know, who, when we were talking about this thing 15 years ago, and I said, I would really like to have a one-size-fits-all inoculant that had a full suite of bacterial, families in it and a full suite of fungal families in it. And he said, I'm running a company, and that's a product a lot of people should have. I'll go make one. And he made one, and now I buy it from him, and it costs me $5 an ounce, which is 4.5 euros for 28 grams, right? That's whatever that is, conversion. And I can use that 28 grams on 23 kilos of vegetable seed. That would be carrots and broccoli and lettuce. Right, 23 kilos of vegetable seed, that's a pretty healthy quantity, right? That's not like, that'll cover some space. So for 4.5 euros, I can get enough inoculant to establish that gut flora, that colostrum on my seeds. And so what do? I open the inoculant packet, I open the seed packets, I take a pinch of the inoculant, literally just a little bit of powder on my fingertips, and I just go like this. I do that for every bag. I just take a pinch, just literally hold the inoculant, the bags are all open, like pinch in here, pinch in here, pinch in here, pinch in here. Then I close the bags, and I shake them up, and I'm done. All I've done is to take the spores of that broad spectrum of bacteria and fungi, and I've put them in relative contact with the seed. It literally takes more time to open and close the bags than it takes to get the inoculant onto the seeds. The cost of the inoculant is effectively zero. It is a profoundly powerful thing to do. Effectively, as I understand it, that's what Johnson Sioux compost is. Johnson Sioux compost is a broad spectrum inoculant that is used to reestablish microbiome in areas where there's been lots of tillage, lots of chemicals, lots of sprays, soil disturbance, and so the broad spectrum of species that were endemic in that area are no longer present. Right? I like to use the example of the snakes in Ireland. Anybody know about the snakes in Ireland? There are no snakes in Ireland. The story goes that St. Patrick came and killed all the snakes, and that's why there's no snakes in Ireland. Anybody heard this one? No. Don't know about this? There's no snakes in Ireland. Right? You need a boy and a girl snake to make more snakes. Right? Until somebody brings a boy and girl snake back to Ireland, there's not going to be any snakes in Ireland. So when all the mycorrhizal fungi has been killed out of your field, somebody's got to bring the mycorrhizal fungi back into the field so they can make babies and that can reestablish. We understand the critical importance of mycorrhizal fungi, but if the agricultural practices that have been applied over the past few decades have caused the genocide, the complete genocide of these species, then it is incumbent on you to reestablish them into the environment if you want them to be present in the future. Now, in principle, once you've reestablished them, you shouldn't need to keep doing it. If you are able to shift your practices and maintain soil life, not keep applying heavy doses of chemicals, then once the microbiome has reestablished, it'll maintain itself. It's not the kind of thing you have to keep buying year after year. If you buy seed every year, and you start your seed in potting soil, then there's that early childhood development phase of the plant, from birth to kindergarten, before it goes back into the soil, where it needs its colostrum, and so then you would be wanting to apply your inoculant onto your seeds because they still have a critical need for that microbiome at that phase of their life. Does this all make sense? Everybody's clear? Nothing too complicated about anything I'm saying?
That inoculation for vegetables, you also work for cover crops?
Absolutely. All seeds, everywhere. All the time. Any seed I'm planting. Olives, I mean, the thing about your olive situation is, if they were olives that were started in a sterile media with no microbiome and salt fertilizer, then they got started off on the IV drip at birth. And you can put them into the soil, but they probably spent too long. I was looking at the olives that are being planted over here in this intensive, wherever it is on the road between here and wherever the hotel is. It's been going in, like, since I've gotten here 3 days ago. It was a bare field, and now the olives are already there. And the people were like laying out the seedlings as we were driving by, one of these times we went driving by. And the seedlings, nice tall seedlings and little root balls. We talked about this. We'll talk about it. Like, you've already traumatized those children so profoundly in that early childhood development phase with no microbiome, with a complete imbalance of the hormones between the root and the top, that a little bit of shift of cover crops, I'm afraid, is likely to not do a lot of good. I'm afraid, as I understand what little bit you told me about how this research project is designed, because of these initial dynamics that are established, it's not a properly regenerative system, right? You're changing some practices post-planting, but early childhood development, people know about early childhood development in humans. It is the most critically important time in the life. The first 1,000 days, from conception to 2 years old, is the most important time for everything in the development of that incarnation of that being. And if you mess that stage up, you're going to have a a child that has to work through their trauma for the rest of their life. They're not going to be open and loving and intuitive. They're going to be cold and dark and fearful and repressed, right? So that's what you've got for the seedlings in your study. So I'm sorry I wasn't able to help you design it. You got through to Amanda and you didn't get through to me.
It's the industry, so we need to adapt to what the industry also does and try to improve it.
Well, if we want to show the industry how to do better,
Yeah.
starting with the seed and doing different from the seed to the transplant is going to be so empowering. If they want to do better, anybody, like if you are working with industry and you want to help them do better, I strongly suggest that this stage in the life cycle is extremely important. Yeah.
What type of inoculants we should use? Because
Right.
now in Portugal we have a lot of companies to sell
Yeah.
inoculants.
Yes.
And our farmer used these inoculants. But
How do you know what's good, what's bad?
yes.
100%. So I told you what I did, and as I understand it, the thing that I use is not available in Europe, except maybe you secretly know how to get some.
I asked someone to bring me from the US.
No. Okay, maybe.
Private delivery.
Yeah.
Yeah.
So maybe we can figure out an illegal shipping system.
They're working on
But they're working on the EU
Yeah.
homologation
Yeah.
at the moment.
Great. So we had this conversation when we went down south a couple days ago to look at this farm that was running beef, and on the way back we're talking about all the materials and products that have been developed in the U.S. for biological farming, and there's some amazing stuff that's like so inexpensive and such small quantities can have such powerfully beneficial effect. And I was just like, is there some way that there could be like a depot and we could coordinate and some of this stuff could be available? Yeah, that's the stuff. Right there.
That's right as well.
This is powder.
We sell lots of tons of seed and we inoculate with the rhizobium and the trichodermas
Yeah.
and so on. More or less 40 grams of product to 100 kilos of seed.
Yeah.
And the problem is that we need to make it in liquid.
Liquid.
And that activates the product.
Yeah.
So they told us that we need to seed at the maximum 2 days after inoculating the seed.
Yes.
The problem is in large scale and in a commercial way of in business to sell seed to send seeds to the south and so on.
Yeah.
The 2 days is not enough to pass a command to prepare the product in the logistic of that. So we need a product not just for legume but to all commercial people that sell seeds or to work
Yeah.
that will be seeds, that we can inoculate the seeds and the inoculation still holds for a long time.
Yeah.
So we can see it.
Yeah. So I'm sorry if I'm taking too long to belabor this point. It's a really important point. What you are looking for in a product, if you're buying a product, and what I really want to teach you to do in a second is how to make your own, because my idea is this is not a sales pitch. I don't like to use labels. I never tell people the names of products ever, on principle. You notice I didn't actually name the product. I just named the concept. The concept is you want a broad spectrum of fungal communities and a broad spectrum of bacterial communities. So trichoderma and one other species is 2 species, not 24 families from this kingdom and 12 families from that kingdom. So broadly, what we're looking for is as broad a spectrum of diversity as possible of multiple kingdoms in contact with the seed. I can't help you. Like, my job is not to help sell products or figure out how to get you products. Personally, I see my job is to help you understand the concept of what you want to accomplish, and then help you be able to troubleshoot so you can determine which product to buy, which product not to buy. Maybe you actually begin to experiment and don't just buy it and apply it on everything, because as I said before, good farmers experiment. You don't just take a thing if someone sold you and do it everywhere, because then you don't know actually if it worked or not. And a lot of cases, I've got a friend of mine who's been in this space for many years. He's got a little microscope. He's looked at a bunch of the liquid inoculants that are out there in the market, and he takes them and looks at them under his microscope and doesn't find any life. And just because it says it's got, it's a whole conversation. first, let me just tell you about the concept of how you can make your own inoculants. Okay, can I talk to you about that? About how to work with the land that you've got and the nature you've got and reestablish from your local microbiome into your agricultural lands? Because ideally, what we want to be doing is we want to be reestablishing from the indigenous microbiome to our land. That's the optimal situation, right? Buying things in as products is nice and well and good, but the ideal situation is to reestablish from the indigenous environment. So I'm going to walk you through a concept here that I call IMOs, or I think it's called IMO. I don't call it IMO, indigenous microorganisms. And this is a very, very simple process. Whenever you guys are done. So effectively, you are obliged to go for a walk, and you are also obliged to bring with you a container of some sort. Whether it's a bag or a bucket, I don't particularly care. If you want to bring your dog or you've got a partner or a child, also fine. But the important thing is you're going for a walk and you're bringing a container. Okay? Now you're going to make sure your walk brings you through as many microclimates as possible. So there's fields and there's forests and there's meadows and there's swamps and there's ponds, right? There's all kinds of different microbiomes in the area or biomes in the area, different climate zones, different soil types, etc. The primary objective here. They stop talking when I stop talking, but when I talk, they start talking. I don't know how to. I like the idea you're talking to each other, but it's distracting as well. The basic concept is that we're wanting to get as many different biomes as possible, which all have their different plant species which grow there, and we're looking for plants that have shiny leaves. So the thing you're tuning your eyes to is shiny leaves, and not managed areas, natural areas. Does anybody know what causes a leaf to be shiny? I heard it. Wax. You're talking. I can't see. I hear the voice. I'm like, it's a woman's voice, but I can't see whose mouth it's coming out of. Yes, wax. It's called the waxy cuticle, the lipid layer, right? Plants do this really interesting thing, which is when they have more food to eat than they need, they stockpile it in the form of fat. Has anybody ever heard of that concept? If you eat more food than you need, you stockpile it in the form of fat. Animals do this. Plants do this also. So when you've got plants that have shiny leaves, that means they're fat and happy. That means they got enough food to eat. If you are a plant that's growing in nature where no one's adding fertilizer, then you can understand that plant must have a healthy microbiome, because the only way it's getting food is through its gut flora, not through fertilizer. Does that make sense? Follow me logically? Yes? Nodding? Yes? Sort of? Right? Conceptually? So you're walking through nature, you're hitting as many biomes as possible, forest, field, meadow, field edge, swamp, stream, and we're looking for the plants of nature that have shiny leaves. You want as many different families as possible. Weeds and trees and everything. So whenever you see a plant that's got a shiny leaf, you want to reach down underneath it and pick up a handful of soil from underneath it. Because if it's got a shiny leaf, it's being fed by a healthy microbiome. The healthy microbiome is in its root zone. So if you take a handful of soil from underneath that plant, you're basically harvesting that microbiome and you put it in your bucket or you put it in your bag. So you're going to walk around and you're going to hit as many biomes as possible, find as many shiny leaf, different families of plants as possible, and put them in your bag. Every family of plants, every species has its own microbiome. So the more species you get soil from, the broader the diversity of microbes you're harvesting. Anything complicated here? All kind of makes sense. It's really, really simple. There's no money involved. Except maybe you have to drive somewhere to find 5 biomes. When you get back home, you take that soil you've collected. I just put it in a bucket. I'd fill that bucket with water, I would not use water from a tap, at least from the city, because if you have this water from a city, they put chlorine and fluorine in it to kill microbes, right? The reason your water is fluoridated and chlorinated is because if they don't, you might have microbes in it that could cause disease. So the reason you've got chlorine and fluorine in your tap water is to kill microbes. So if you add tap water to your bucket, you'll kill the microbes. So you have to get some other source of water. Rain's a wonderful source of water, if you can get rainwater. Beautiful source of water. And then, so you add the water, you stir it up a little bit, so it's all nicely mixed up. Then you let the soil fall to the bottom, and then you have standing in suspension a whole suite of microbes from your local area. So what I would do is if I was starting seeds in my greenhouse or whatever, in a cultivation shed in a potting soil, I would just put that water into a watering can, and I would water that onto my seeds. If I was starting seeds in a row in the garden, I would water that onto I'd plant the seeds in the row, water them, and then cover it. If you've got seeds in a seeder in a big tractor, water onto the seeds before you dump them into the tractor. Or once you.
But do we need to do it before seeding?
Before seeding, because that planter is going to leave the seeds covered, so you can't water.
For instance, I cannot inoculate the seeds and then wait 2 or 3 days or 1 week and then seed it after.
Correct.
I cannot do that. We need to inoculate it to seed directly.
Yeah. So the thing about this is, and there's a couple of important points about time, is microbes in many cases are aerobic, and so if you leave them in that bucket of water for 2 hours or 4 hours, they will breathe all the oxygen out of that water. They'll use it all up, and then they'll die. So you don't do this today and then use it next Thursday, right? It's you do this in real time. That's one important thing. A second important thing is if you have ever taken any course that talks about adding wheat bran or rice or molasses or kelp and bubbling it or letting it sit for a while, you completely shift the microbiome. Right? If you add kelp or you add molasses and you bubble it, there's certain microbes that will flourish in that environment, and almost all the rest of them will not. We had John Kempf on our conference this summer. I'm not sure if some people were able to listen to him speak. There was a really, really important point that he shared as part of that conversation relative to this. And that was that 90% of soil microbes only reproduce in the presence of a living root. 90% of soil microbes only reproduce in the presence of a living root. So this is why I don't talk about the Johnson-Su bioreactor. This is why I don't talk about compost tea. It's why I don't talk about KNF.
Yes, I was going to ask. You don't use it, you don't.
If 90% of the species of life only reproduce in the presence of a living root, how can you possibly get a broad spectrum of microbes from compost tea? How can you possibly get a broad spectrum of microbes from Johnson-Su? How can you possibly get a broad spectrum of microbes from KNF? It's wonderful that people are talking about microbes now as a positive thing, because 40 years ago, all bacteria and fungi were considered to be pathogens, and it was completely common knowledge that bacteria were bad and fungi were bad. Now we've got all kinds of different groups with certifications and courses, and you pay $5,000 to learn how to do this, and $1,000 to get this certification, and you can attend this course for $500 to learn how to replicate microbes in an unnatural fashion. That's not comprehensive. It's not how nature does it.
Just a quick, it goes along with what Zaire was asking, is if our intent is not to reproduce, but it's just to inoculate the seeds. So we do all that. We inoculate the seeds, they dry.
Yeah.
Can we then save them for some time until we, so can these
They may go into a spore form.
Right.
I don't know. I would say What I'd like to do is get them from the living route that they're on
Yeah, that's
into another living route as soon as possible.
But operationally, sometimes it's hard, especially when you work with thousands of hectares. Like how can you?
So how does nature do it? Always go back to the question, how does nature do it? Always go back to the question, don't ask Dan, don't ask a company, ask how does nature do it? Nature puts a healthy gut flora. She has the colostrum for her babies, right? When you've got a healthy mother, that seed is in a, what is it, in a fruit, in a case of some sort that falls to the ground. That microbiome is on the bean, like the pod. It's in the tomato, right? And as that thing slowly digests and ferments, the mother's microbiome is set into the seed, actually into the seed. And you'll have 6 billion microbes in every seed, or 5 billion, or 4 billion, or 10 billion, literally in the seed.
So in that order of ideas, if we have a seed that sometimes stays for 6 months without germinating and still has microbiology because
it's in the seed.
it stays there.
But the question is, what was the health of the mother? If you're buying seed from a mother plant that was fed chemical fertilizer and sprayed with insecticides so that she didn't die before she reproduced, she didn't have a healthy microbiome, right? It's so simple when you think about it. So if you're buying seeds from a different biome, right? If the seeds you're buying were raised in Italy or they were raised in who knows where all, different soil type with different health of the mother is critically related to the health of the baby. You want to have seeds from healthy mother plants. We'll talk about that as well. That's one of the topics for today is seed quality. I'm sorry, I'm getting onto my ramble here. This is actually the topic for today. This is one of the key topics for today is seed quality and sourcing seed and where you get it. And I'll say it now, I'll say it again. A lot of the things I'll talk about, you can address in short order. You can take a soil test, you can get the mineral balancing done, you can, get your cover crop seed, you can get them planted, you can mulch, there's a lot of these things I'm talking about. If you just focus and go do them, you can get them done in, 2 weeks. Seed quality, it takes 2 or 3 years. You have to take the seed that you have access to, and you have to grow it well, and harvest that, and then grow that again, and harvest that. And you can take the degenerate seed that most of us start with, and revitalize it through epigenetics in 2 or 3 generations. But it's going to take 2 or 3 generations.
So technically for a seed farmer like Zach, if he does all the correct practices, he doesn't need to worry about inoculating the seed because it's taken care of.
If he's got healthy plants,
If you have healthy plants,
he should never buy any seed from anybody. He should just take his best seed and plant it.
you don't need to worry about inoculating.
100%.
Right?
Once your microbiome is well established, if the mother plant is healthy, if you get to that 12 bricks reading in the leaf, if your plant is pest and disease resistant, those seeds from that land are the best things to put back on that land because that's what nature does. Nature drops the seeds on the land where that plant grew. What does nature do? She plants the seeds from that land back on that land. No? Yeah. So once it's established, you shouldn't need to buy microbiome. Once the minerals are reestablished, you shouldn't need to buy minerals. Right? All these things are just simply to address the imbalances that have been caused based on the things that have been done over the past decades and centuries from a place of ignorance. Right? Indigenous cultures weren't buying seed, they weren't inoculating, they weren't mineral balancing. They were gently with light touch, doing a little bit of fire here and stuff like that. And producing fecundity. So, yeah. One last thing about inoculation is that was the seed inoculant or the soil. There's the other thing which is the leaf inoculant. And so you're simply, if you want to make a foliar inoculant for the foliage, because the microbiome of the plant is also on the leaf surface and in the leaves, and you want to reestablish that indigenous microbiome from the environment to your leaves of the plants you're growing. Is you do the same exact process. You look for these shiny leaf plants, except you go and you take the leaves off of the plants and put them in your bucket. Instead of taking the soil you take the leaves. I would ask politely, I would say thank you, I would engage in some sort of just moment of appreciation in the process of ripping a few leaves off of a plant. But you stick them in your bucket, you stick them in your bag, you go back home, you add the water, which is not this chlorinated water, but the rainwater. You know, get them in there and you just work them up, you know, like you're, yeah, just get them up in there. And once it's in the bucket of water, you want to just give it a good once over. And then you take that liquid and you put it in your sprayer. And you'd spray that onto the leaves of the plants. So you're just harvesting the microbiome from the leaf surface, from nature, and you're applying it to the leaf surface of your plants. So these would be ways to take indigenous microorganisms from your local area that have evolved in this climate zone and this soil type, that maybe haven't been abused quite so much as the land that you're growing your crops on, and bring them back in. That would be, I think, a wonderful, simple, inexpensive way, no money involved. You do have to go for a walk. But other than that, you don't have to buy anything. For me, if we can explain to people how they can do things with nature, from nature, not have to buy stuff, you should always have that in your back pocket. And then you can consider buying things if you want. It's, you know, if you want to buy things, great, awesome. Explore, experiment. I'm not saying don't buy stuff, but be empowered to source everything you need from nature, because nature does have pretty much everything we need. I'm getting a sense of time maybe coming up for a break, 10:15. That's been an hour and a half. 10:15, 10:30, okay, 15 minutes. All right. Any more questions on microbiome? Yeah.
The inoculation, I understand the inoculation on big chickpea seeds and big legumes, but for example, what if I want to inoculate carrots, like with a liquid messing, like how do you?
I would, so I.
The seeder will not grab the seed and get stuck everywhere.
I never use seeders personally. I find them to be far too much of a pain in the butt.
As you say, with the spoon.
The dry matter.
A dry, if you've got so the dry powder I use, whatever seed packet I've got, I just put a pinch of dry powder in there. But on my farm, I take my hands, I put the seed in my hand, and I just go like this. And it goes a lot faster than a seeder. And I don't need to prepare the soil, the seed bed, to be completely flat and with no bumps or bubbles or rocks or anything else. I'm not sure if anybody else has tried using seeders, but like those seeders, the amount of destruction you have to do to the soil structure to create a seed bed for the seeder to work, I would consider to be an inappropriate level of tillage and soil structure destruction. So
Depends on the seed. Some of them are like direct seeding.
if you got a big tractor and you've got in your right, I've never seen a walk behind seeder that can deal with bumps and rocks and chunks and roots.
But you can tilt it, like superficially with a tilter and like.
You can just make it
Okay, you can sacrifice 1 centimeter, 2 centimeters.
I do tilt it with one pass, and with one quick pass with a tiller, I never get a completely perfect seed bed.
Yeah, it's hard.
That's right.
So, anyway, yeah. In my reality, when you get good enough, you just walk along like this, or you walk along like that. And which
If you have to make 50 beds of
no, carrots are like this. Yeah.
Because the problem is then thinning and there's a lot of labor.
That's where you get.
Yeah.
Actually,
Could work.
when you get that bacterial fungal balance right in the soil, and the weeds, we talked about bacterial fungal balance a minute ago. If the things we call weeds, those early adapter plants, those in the cycle of nature covering herself, because she's a modest woman, she likes to keep herself covered, right? In nature, soil is generally covered, it's not bare. There's certain plants she uses to cover herself right away after soil's been disturbed. After soil's been disturbed, the fungal kingdom has been knocked out, the bacterial kingdom has been knocked out, the bacteria come back fast. So it's a bacterially dominant soil. So the plants that we call weeds prefer a bacterially dominant soil. So if you, and most of the compost is bacterially dominant, so when you put the compost down, the weeds start germinating because the compost has been turned, which has made it bacterially dominant. If you manage your soil in such a fashion to maintain that bacterial fungal balance, the things we call crops will outcompete your weeds. So personally, I'd actually rather have my carrots relatively evenly spaced across my 4-foot bed than just in a row with a bunch of empty space in the middle. So actually, I do this with my carrot seeds. If you dial it in right, if you manage the soil appropriately and you shift the bacterial fungal balance, the things we call crops will outcompete your weeds. We haven't really talked about pest pressure and disease pressure yet, but when you see the larvae and the fungal pathogens eating the weeds and not eating your crops, only then are your crops what you should be harvesting and feeding to your customers. If the diseases are attacking your crops and not attacking your weeds, the weeds are healthier, they're more nutritious, and that's what you should be feeding your customers. Anybody heard of callaloo? It's a amaranth. It's used in, it's an African plant. It's an amaranth. Callaloo? It's a wild weed. It's a weed, right? It's a staple in a lot of African cuisines. Yeah, it's a Chenopodium. We call it pigweed. Where I come from, we call it pigweed. It's a weed. It's a weed. It's a weed. It prefers a bacterially dominant environment. When you have a bacterially dominant soil, it'll grow fast, and your spinach and lettuce will not. It'll grow faster than your spinach and lettuce when you've got a bacterially dominant soil. When you've got a balanced bacterial fungal soil, the pigweed will get eaten by the larvae. It'll get attacked by the, what are they called? The little red guys, the aphids, right? Nature's telling you what's fit to harvest and eat and what's not. When those things we call weeds are growing faster with more vigor, they are more nutritious. Your crops are only fit to eat when the weeds are being attacked by insects and disease, and your crops are growing more vigorously than your weeds. If you're respecting nature's communication, that's the communication she's offering you. So you have to get that to happen, you, among other things, you need this balanced bacterial fungal dynamic, which means you have to minimize the disturbance of the soil. But my experience is the carrots will outcompete my weeds. So I prefer to have them a little bit more evenly spaced across the bed. And weed pressure with carrots is killer. Anybody who's ever tried weeding carrots, like when the weeds, if you wait too long and the weeds they jump up and the carrots are underneath there, it's like you take out the climax forest and you leave the understory, right? It's a total massive amounts of work. It's just a horrible effort, right? And that happened because the bacterial fungal ratio in your soil was off. Yeah.
Very useful to explain the right fungal ratio for most of the crops we have.
Which has to do with tillage, which is again on my slideshow for today as a topic. But yeah, effectively, tillage, as I said, when you turn the compost, you know, the effective, I did say this yesterday, if you haven't engaged in genocide recently, take a tiller out for a quick spin. You know, in 5 minutes, you should be comfortable that you've killed off a few 100 billion organisms. Yeah? It's really simple. Right? There's a whole massive ecosystem down there. They say that there's 4 billion microbes in 1 teaspoon of soil, or 10 billion microbes in 1 teaspoon of soil. Yeah, teaspoon, you know what teaspoon is?
Yes.
Little spoon? Yes. Yeah. I'm getting blank looks. Is that not because I'm not converting it to metric or what? No. 1 cc? I don't know what it is. 1 cubic centimeter? Yeah. So there's a whole ecosystem. They've all got their spot. They've all got their little ways they breathe and where they get water. There's a whole massive ecosystem in there. I like to use the metaphor of a city. Just 1 second. I'll just sort of conceptually. If you take a big city, I like to use the example of New York City. People may have a concept of New York City. right? There's big, tall buildings, and there's roads in the middle. If you take that road, call that road is, I don't know, 20 meters across, 15 meters across is the road, and you would take a rototiller that would run down that road, call it, it'll go down 3 meters or 5 meters, like just to scale. If you took that rototiller down that road in the middle of the city, you're going to shred the water lines, the sewer lines, the gas mains, electricity, fiber optic cable, all the infrastructure that facilitates life for all the millions of organisms that are living in their little boxes, right? You don't need to actually have the tines of the tiller kill the microbes, kill the humans in the little boxes. If you shred the network with which they're able to breathe and eat and get rid of their waste and communicate, you're going to have mass die-off. If you took a rototiller down each of the roads in New York City, up and down each of the roads, all the people went running off, which microbes can't do. It would be impossible to maintain the population density of humans in that area after going through with that tiller, because all the infrastructure that facilitated their life would be destroyed. Does that make sense? Yes. The act of going through soil with a rototiller creates a dynamic where mass die-off occurs because the capacity for life to exist at the level that it was existing is no longer possible. So there's a reason why people talk about no-till. There's a reason why people say it's not a good thing to do. From a practical standpoint, if you're growing annual crops, preparing a seed bed is, kind of important. So what I do at my farm is I've got a tiller that's, 4 feet across, a little more than a meter wide. I've got my beds that are, it's like, these are beds, right? This is a pathway. There's the bed, there's a pathway. We get lots of rain sometimes, like we'll get 20, 30 centimeters of rain at a time sometimes. And so we have to have ways for the extra rain to leave the field, otherwise there'll be no air in the soil. So I have these things called pathways. And then I'll have, of course, I'll run drip tape through here to maintain hydration during a drought. But what I do is I'll come through with a rototiller and I'll just disturb this top 2 centimeters to prepare a seed bed, this till thing you're talking about. Yeah, exactly. So whatever mycorrhizal hyphae was going on down here is still established and untouched. And so, sure, you're going to cause some die-off here, but you're going to effectively maintain that level. If you don't disturb the soil, nature evolves from bacterial dominance to fungal dominance. The natural progression of soil is from bacterial dominance to fungal dominance. And so, if the issue is with weeds, that they prefer bacterial dominance, if you minimize the disturbance or don't disturb the vast majority of the soil, you engage in tillage only occasionally and only prepare a seed bed because you have to be efficient because you're trying to make a living. In my understanding, that's a way to maintain that bacterial fungal balance, which is critical for the plants that we call crops to flourish. It creates the microbiome that's more appropriate for them than it is for weeds, which allows them to outcompete the weeds. Right? Again, what you want to see is your plants growing faster than the weeds. That's nature telling you this environment is fit for your plants. There was a question yesterday, I think, about non-native plants, bringing in plants that aren't natural to here, like tomatoes in Italy, right? They're not from Italy. Like, you shouldn't have tomatoes in Italy if you believe in not having, growing plants that are only from where you are from. There should be no potatoes in Ireland. There should be no corn in Portugal. There should be no beans in Portugal. There should be no tomatoes in Italy. So let's just deal with the fact that we bring plants in and we share them around the world, and let's be okay with that. And understand that all these plants, while they maybe didn't evolve in one spot, can function just well in that spot if we create an environment that's appropriate for them.
And
Bacterium.
Bacterial. It's for all the crops or some crops, or like you said, commercial crops that's like some more.
As I understand it, the vast majority of the things that we call crops that are annuals prefer about that 1-to-1 balance. The more you go towards perennial, the more you want a perennial dominance. So I see all these olive trees around that people come through with their tillers, and they till up the soil around the olive trees. The olive tree is a perennial plant. It prefers a fungally dominant ecosystem. So when you come through, when you till the ground underneath that olive tree, or the grapes, or any of those perennial plants, you are shifting the microbiome to that bacterial dominance, which is not what those perennial plants prefer. And that's causing a situation where they're not getting their needs met. It really is, yeah, sacrilegious.
Can be helpful.
Sure. I don't know if I know that graphic or not, but you obviously, we got a great student here who's been reading all the books and watching all the courses and everything else. I think we're at the 10:30 time for a break, but you want to put this thing up and we can have a show? Yeah, it's fine.
Conversation.
Yeah.
Can I just ask in the meanwhile
Yeah.
if the technique you were mentioning about like just reactivating the indigenous microbes is
Mhm.
similar to KMS in Korean natural farming. So KMS and KLF. So the KMS is basically the activation of indigenous microbial life through the same principle. So collecting soils from your field, putting it into water. KLF is basically leaving for a week time some things to rotten out in a
Yeah.
liquid, in a jar with two-thirds filled with water.
Mhm.
Rotten it up to basically, with the KMS, activate the microbial life, and KLF is the food of the microbes to be able to survive. Is it the same thing?
I honestly haven't taken many of these courses or studied too closely about these things. I thought KNF, or I've heard of KNF, but not KLF.
KNF is kind of the general.
I know that some people are,
No, KNF is Korean natural farming.
Yeah.
But KMS and KLF are two biosolutions basically that you can create.
mhm.
And it sounds like KMS is like activation of dormant microbial lives, and it's present in the soil, but you activate it basically by putting, you create a tea bag. You
Mhm.
put the soil that you collect across the field.
Yeah,
You put a jar with two-thirds of water.
yep,
Then you put starch, potatoes, basically, inside.
yep,
To be able for these microbes to activate and start eating, and then this water, after stirring it for I think 24 hours, becomes like alive, so activated microbial life, and then you start spraying or
Yeah.
releasing it in your fields because it's like dormant microbes that were activated and start doing their job. So this is activation of microbial life, and the KLF is just an LF is liquid fertilizers.
yeah,
But it's basically the same principle, a jar, two-thirds
Water.
with water.
yeah,
And then you rotten in any kind of thing like tomatoes, anything that can rotten out and
Yeah.
create like things that microbes can feed on.
yeah,
And then after a week time, it smells like decomposition.
yeah,
You spray it after the microbial life that you activated so that so the microbe can feed on this liquid essentially.
yeah,
It sounds like a bit of the same.
But you're not, then you're feeding the
Yes.
microbes. So you're shifting, that's what I was referring to. If you don't feed the microbes, you have the whole, I think I understand.
yeah, also,
If you feed them with something, whatever it is, you're shifting the.
so if you think you're activating microbes by taking soil and putting it under water and mixing it with potato starch.
Yeah.
So if it's underwater, it's anaerobic.
Yeah.
So there are obviously anaerobes and aerobes.
Yeah.
I think the point that John made in his course, which I've never heard anybody say like on the record formally, I've heard it here and there, that 90% of the species are only reproduced in the presence of a living root. Means that you can have certain species of microbes that are anaerobic, that like potato starch, that will reproduce. The reason that that microbiologists have not named 98% of the species of soil life is because they've only been able to study the microbes that reproduce in a petri dish that are fed agar. So there's a very small percent of microbes that will reproduce in a petri dish when fed a foodstuff that comes from kelp. I think agar comes from kelp or whatever it is. So we understand that there's massive quantities of different species of soil life, but we don't have names for most of them because they can't be studied in a lab because they only live in the presence of roots, of living roots. So you can reproduce a certain subset of species in specific environmental conditions. And so I've heard about these techniques where people are taking rice bran, or they're cooking rice, or they're taking bones, or they're taking dead meat, and they're sticking it in the ground, and they're fermenting it for a while. And so what you're doing in that case, or with the compost tea, when they're taking compost and they're putting it with water and kelp or molasses and bubbling it for 24 hours. What you do in that case is you are reproducing high quantities of a certain type of species who can live in that environment. And so what I'm saying is, as I understand it, diversity is the way of nature. As polycultures, diversity, symbiosis, quorum sensing, all that stuff, all the magic power of nature to be able to do well in droughts, in floods, not need fertilizer, etc., happens in the presence of diversity. It's only when you have all the different species working together that these beautiful dynamics occur. And so all these techniques that are teaching you how to reproduce microbes are functionally selecting for a fairly small set of microbes. And just because someone's teaching a course, just because they offer a certificate, just because it costs a lot of money, just because there's good marketing, just because lots of other people have been doing it and are talking about it, does not make it the way nature would prefer to have it done. The problem, I think, with a lot of the movement is that people who don't know what they're doing are told by 10 people that this is a thing to do because those 10 people didn't know what they were doing and had somebody else tell them by somebody who was trying to sell them something. And we can track these lineages of the movement. I'm trying not to say names of certain certifications and companies, just to be polite. But if you track it down, it comes from someone trying to sell a service or a course or a product, and it doesn't seem to be in line with the way nature does things. So what I would say is, don't trust me, don't trust them, trust nature, experiment, do this right here, do that right there, and see how your plants grow. If you do this right here and you don't do anything at all right there, and things are just the same, then it's not doing much benefit. We'll talk about the refractometer and the as a tool to measure plant vigor and vitality later today a little bit. And we'll talk about it much more deeply in the second half of the course. But to be able to have some metric to be able to test whether something is true or not, for me is a really powerful empowerment as a farmer. Because how do I know? It may be this potato starch is God's greatest gift, and I don't know about it. But the way I would know is I would try it, and then I'd measure my plant health. And I'd see if it dramatically improved my plant health, decreased it, or had no effect. So again, I don't know a lot of these things. All I know is I'm pretty sure, my basic sort of guiding light is how does nature do things? And if what somebody's teaching you to do is somehow out of line with the way nature does things, then I'm going to say it probably isn't right. So I don't know. It's really exciting to learn all these techniques. You get really excited. I see all the people getting microscopes out and they're making ferments and teas, and I'm like, oh. And what's your pest pressure? And what's your yield? Yeah.
If I just
Add something. Yeah.
Just to say that when you are feeding the microbes, what I think we have to understand is that when we have bacteria or fungi, we have a diversity that is
Yeah.
So we are talking about kingdoms, so it's like mixing or having a mixture of man, rats and ants and, all the animals that you
Yeah.
can think of. And now, when you're going to feed some, you are just creating the conditions for those that can grow faster, okay?
Yeah.
And some of those are not the ones that are more interesting for what
Yeah.
you want to do.
They could be pathogenic.
So you are changing your community in a direction that is not exactly the one you aim at. But you can grow using other media that directs or changes your community in the way you want it to go.
Yeah, I think, I don't want to be, throwing water on the fire, but of passion and excitement about it. But yeah, experiment. Yeah, we're at past our 10:30. Thank you for this. Perennial grasses, bare rock, what do we have there?
Okay, yeah.
Annual grass, levels of disturbance. Okay. This looks like a permaculture perspective. I'm not seeing like annual vegetables on that list.
We can
Yeah, you can see, exactly.
We can understand the weeds.
The spectrum of variation.
Some are for year.
Yeah.
And the crops will be for year, and after we have
Yeah.
trees and forest and
Yeah. Perfect. As usual, any topics that come up during the break that people want to address? No? As and when? Okay. I had a question about like sort of a practical how-to, like a case study. After everything I've been saying, your question was, let's take an example of one farm that's in a certain situation and walk through what would be a protocol of things that could be done. I think it's nice to balance out the sort of the vision and the concepts and the sort of the broad principles with the practical how-to. I think we'll have time this afternoon to go out and walk around on the farm and look at stuff, which is always exciting to do. But also, let's talk about conceptually. You want to just frame your question again? Give me like a specifics of a farm you're thinking of that's around here that's struggling, and we can walk through what would be some strategies that farm could do in order of priority, et cetera.
I would like to do it in my area, and my area is on the coast, so we have super high relative humidity over all year round. But after I am on sandy soil, really like the beach sandy soil when you go to beach, so this kind of type soil. And we have in the summer maybe 3-4 months without rain, so the irrigation issue. We are in the area where now the irrigation is fed from one dam, which is, let's say, decreasing because there is no rain to feed it. So we are kind of struggling now with the water situation in that area. And so I have low organic matter in the soil, and they are quite poor. Let's say I didn't do lately any analysis, so no, let's say, information on this. And I'm growing vegetables, kind of. So what I need to do to keep growing, because this is something which gives me money to survive, and make the transformation change to be regenerative.
Okay. What's the scale?
Let's say small garden, market garden. Even they are bigger farms. I'm speaking now small scale, but the farm where I was working, it has 200 hectares.
So a small market garden and a 200 hectares are two different scales. So we'll start with your garden. Okay. So soil cover is extremely important in my mind. I've talked about mulch. I personally on my farm use what we call hay, mulch hay, which is basically after the hay is cut, before it gets baled, it gets rained on, and then it's not fit for animal food, or people don't think it's fit for animal food. And so they sell it for not much money. So I get big round bales for $30 or square bales for $2, and I use that very generously on my land at all points in time. Presuming you don't have that, do you have access to seaweed? Seaweed? Kelp?
Product seaweed.
You live close to the ocean?
No, then I will go take it from the ocean.
On the beach?
I don't know if is it seaweed, the big one. Which
All
is
that
around
stuff that
the
shows up on the
but
beach?
we have in the tide when it's going, sometimes it's coming, let's say, different.
So if you have a garden and you live close to the ocean, I think probably one of the best forms of mulch is seaweed. Well, regardless of where you live in the entire planet, I think one of the best forms of mulch is seaweed. So if you live close to the ocean, what do you call it? You don't call it seaweed? What do you call it? Algish. Algish.
And there can be different ones.
Yeah.
Different ones.
But
Yeah.
actually, that's illegal to collect.
Huh?
They are on the beach outside of the hotel.
What happens to it? Does the city pick it up and put it somewhere? They just
It's going back to the ocean.
No, sometimes they pick it as
No,
well.
they keep, but if I have
Yeah.
from
I know
the
in our area where it's
Okay, we haven't had the civil disobedience conversation yet. I'm a big fan of civil disobedience. Yes, absolutely. You raise your hand and ask it, and we'll talk about it. Remind me. So, as far as I'm concerned, just on principle, seaweed is one of the most valuable mulch materials that God has ever invented. So it's a very high commodity, a high value commodity, and I would, whether you want to do it legally or illegally or whatever your protocol is, I don't particularly care. I don't think the government I didn't give the government the right to tell me what I could and couldn't do. That's how I see it. So in most cases, if I think I'm doing something that's soil beneficial, that's environmental beneficial, I think I have a responsibility to do that. Anybody heard of this guy named Thoreau? Henry David Thoreau? On civil disobedience, Walden Pond. I'm not sure what the people know. You know about this? Henry David Thoreau was an author. He was a philosopher. He was an activist in the 1800s in Massachusetts, where I'm from. And he built a cabin on this pond, on Walden Pond, and he wrote some books. And he wrote one book it's called On Civil Disobedience. And I can't remember what he went to jail for, but the government said he should do something or pay some tax for something, and he said, no, I'm not going to. And so they went and put him in jail, and he sat in jail for 2 weeks, and finally they let him go. Because they're like, it's not worth our hassle to have you sitting in jail for 2 weeks for some stupid little thing. The whole American Revolution came because people said, we don't want to be taxed for something to pay for the crown, because we want to have the right to choose what's we can and cannot do. Taxation without representation, the whole concept of, we should have the right to choose as the people what's right and good and bad. And what I experience as I travel around the EU is that there's a lot of regulations that come from the top. When I was in Italy a couple of weeks ago, they were telling me how it's basically illegal to have chickens outside.
Here as well,
No, I mean, it was basically like anybody who had chickens outside was getting fined heavily, or,
Have you ever been to Scandinavia?
I just went to Sweden last week.
Yeah, there was full of regulations.
So, I mean, we can talk about the rabbit hole of what the rationale is behind telling people that they can't have chickens outside. But the first question is, who gave the government the right to tell me? And if the government says, I can't do it, should I just then therefore do it, even if it doesn't fit with my principles of what's right and wrong? Can we talk about this? You want to talk about it? Anybody else want to talk about it? If you don't want to talk about it, we can move on. But for me, it's an important conversation. I mean, the whole thing about bird flu, right? The bird flu was the rationale for wanting to not have chickens, because the chickens might be a vector for bird flu to be transitioned from wild birds to the birds in the confinement operations. Anybody heard of this guy named Pasteur? Louis Pasteur? Pasteurization? Yeah, pasteurization, Pasteur. You've heard of germ theory, this concept that there's a germ and in the environment that you'll get sick. Yeah? Do you remember in the olden days, like before 2020, when if you were in a room and someone was sick and there was 12 people there and you were sitting for a meeting for 3 hours, doors were closed, one person had a sniffle, you could get up and go home and maybe one out of those 12 people would get sick, but the other 11 would not get sick? Does anybody remember that? Yes, we're still, that's not too far in the history that we can remember that when that happened, right? So germ theory says that the presence of the pathogen is connected to the presence of the disease. So when the germ is there, you'll get sick. That's germ theory. That was Pasteur's suggestion, and it got very popular. Pasteur had a contemporary whose name was Beauchamp, Antoine Beauchamp, and Beauchamp proposed terrain theory. Beauchamp said, if the host is susceptible, the pathogen will infest and the host will become sick. But if the host is not susceptible, the pathogen will not be able to infest and the host will not become sick. So I would think that that would be what we would have seen historically when we're in the presence of somebody who's got a cold, and some people get sick and some people don't, is some people had a biological terrain which functionally was an immune system which was strong enough to not become sick in the presence of the pathogen, and other people didn't. So apparently on his deathbed, Pasteur said, Beauchamp was right. He was like, he realized at the end of his life that germ theory was not true, that it wasn't the presence of the germ that correlated with the disease, it was the immune system function of the host. And so, during COVID, the rationale for everybody getting locked up and wearing masks was germ theory, right? The presence of the germ, if you get exposed to it, you're going to get sick, so therefore we can't get exposed to it, therefore we should all be separated. Which, as I understand it, is effectively the rationale behind the chickens not being allowed to be outside in northern Italy, is because if there's a bird flying through with bird flu and it poops and somehow a chicken who's outside gets exposed to it, that chicken will get the bird flu and then be a vector for transitioning that bird flu to the chickens in the confined chicken environment. The logical conclusion of that then would be to remove all birds from the environment. Right? If we're following logic, the chicken's only going to get exposed to the bird flu from a bird flying overhead. A chicken is just one of many birds that are in the environment. So why would we want to take these birds out and not take all the other birds out? If the bird flu comes from the birds that are flying overhead anyways, if you were logical, if this was strategically, tactically, practically what you were trying to accomplish, then the appropriate thing to do would be to remove all birds from the environment. Now, the first question I would say is it nature's way to have chickens in that confined animal operation? Is that the appropriate way for chickens to be raised? And if the chickens in those environments are so susceptible in the first place, maybe that's nature telling us that they're not fit to live anymore. Maybe, we talked about this Nature's Report card yesterday. I talked about the pest pressure and disease pressure. Remember that? A little bit talked about that? Yeah? So, I mean, there's a whole thing we can unpack here. But as I understand, it's the biological terrain that actually correlates with the immune system function. And so if you've got healthy chickens outside on grass, which is what chickens are supposed to be doing, eating worms, eating insects, perching on trees, they're not going to succumb to the bird flu. In fact, the quality of the eggs from those chickens, the nutritional value of the meat from those chickens, is going to be superior to the eggs and the meats from the chickens in the confined animal operation. So if we're making regulations to remove the animals that are healthy from the environment, so that we can maintain the animals that are unhealthy, so that we can produce food that is nutritionally inferior for humans to eat, so they can be less healthy. The logic behind this regulation that you shouldn't have chickens outside is flawed. So in that point, the question becomes, just because the government told me I couldn't, is that a reason why I shouldn't? I think I want to digress for a minute onto a different topic, was a tangential topic, which is part of why we went down south a couple of days ago, which has to do with one of the things I've come to from doing this research with beef, which I think is extremely interesting. And that is, I think we talked about the omega-3, omega-6 ratio as one of the compounds that correlates with what the cows are eating. And omega-3, I said the ratio from 6 to 3, below 2.5 to 1 is what people who've been studying human health, humans, over time and looking at their bones, et cetera, had determined was the ratio in our diets over millennia. The ratio of 2.5 to 1 or less. That's what the American Heart Association says. Anything more than 4 to 1 is bad for us. What we found in our beef study was that cows that finished their lives eating grass, eating green stuff, not just grass, of course, forbs and all kinds of other green plants, they averaged at 1.7 to 1. And the cows that were finishing their lives eating grain averaged at 7.8 to 1. Again, anything more than 4 to 1 is, according to the American Heart Association, which takes money from all kinds of, food companies, is anything more than 4 to 1 is bad for you. There's the issue, however, of finishing a cow, right? So around here, it's really dry in the summer, and those calves that may be able to eat grass for their first few months of life, when the rain stops coming, the grass stops growing, there's not enough left there for them to eat. It's hard to get them to the weight they need to slaughter, and so the farmers sell those calves to feedlots where they finish them on grain. And so basically all the beef you have access to is at that 7.8 to 1 or 12 to 1. That was average, was 7.8 to 1. So it could be 6 or 12 or whatever, which is part of why I think Paulo's got me over here in the first place. He's like, I have a company that sells meat to humans, and I want to be able to sell meat that's healthy to humans, and I can't buy healthy meat from farmers anywhere in this country because all the animals are being fed grain at the end of their lives, not grass. Is that a fair characterization? So one of the things that I've come across, and we had in our conference this summer, for those who are aware of it, and I think the recording's now on our YouTube page for those who want access to it, was this concept of fermenting fodder. So grass, for those who don't know, is full of cellulose. Cellulose is a compound which is difficult to digest. And if you take that cellulose and you ferment it in a sort of silage type environment, so in the presence of an anaerobic set of species, and you outside of air, outside of oxygen, that grass can be pre-digested. So in the same way that sourdough bread, is more bioavailable, or sauerkraut, or kefir, all these things that we do where we have microbes, cheese, yogurt, right? We have all kinds of traditional foods, the traditional salamis and all the, I was in Italy, it was amazing. All the meats that they have, I'm like, my Lord. It was all traditionally was fermented. These are fermented, right? It's a slow ferment, and that actually improves the bioavailability and digestibility of these things. These are the traditional foodways. These are the indigenous foodways of people from this continent, is to ferment their food. This is the Weston Price story, for anybody familiar with Weston Price. What's Sally Fallon's book? Nourishing Traditions? Yeah. What's one of the world's best cookbooks? You got it in there? Beautiful, wonderful. Helping us go back to our traditional foodways of food preparation and preservation that has been done for millennia, that helps people not get disease in the first place. So if you take that grass when it's green and you cut it, chop it up, mix it with the ferment, and sile it, make silage from it, 3 months later, it's pre-digested, much more bioavailable for the cow, the cow needs to use much less of its energy it gets from digesting the grass to digest the next mouthful of grass, because the microbes have done a lot of the work to pre-digest it. And so actually, they can gain weight at the speed they would gain weight if they're eating grain. So we can match the weight gain of grain finishing with fermenting fodder with cows. So the opportunity here to create a reality where we don't need to be finishing cows on grain means we can have beef that is more nutritious, that's more health beneficial for us. As well, there's a minor corollary, which I'm being sarcastic, not minor, massive corollary, which is if we don't need to feed cows grain, then all the land that's used to grow grain for cows doesn't need to be growing grain anymore. I talk about Brazil whenever I have this conversation, because anybody's familiar with the Amazon, right? Or what used to be the Amazon, parts of it that are being cut down and turned into growing grain for animals? If we can finish our animals on fermented grass, that means we can grow perennial polycultures, make hay out of them, and then we don't need to be growing corn anymore. That means you don't need to buy the seed, that means you don't need to buy the fertilizer, that means you don't need to buy the herbicide and the insecticide and the fungicide, right? We don't need to be cutting down the trees. We can have perennial ecosystems with deep-rooted plants that are able to build soil, that are able to hold water in the middle of a drought, right? If we can facilitate a dynamic where the feeding of the animals is done by perennial polycultures, then that's the way we can begin to reverse climate change, right? That's the way we begin to sequester carbon, heal the water cycle. Remember we talked about the cloud formation and the albedo effect and how that water cycle can cool the area. So the opportunities here are massive. Similarly with pigs, if you take a polyculture pasture mix and you ferment it, pigs can eat that and get their nutritional needs met. Also, if you take these ferments, the microbes, and you add them to the grain for the pigs or the chickens, that will support their gut flora. They actually, as their gut flora is functioning more well, they will need to eat less grain to gain the weight at the speed that they normally gain. And as well, with a healthy microbiome, they're 100% resistant to bird flu or swine flu. So we've got this happening in the US where farmers in the confinement animal operations at 100,000 birds in a house or 5,000 pigs in a house in one building are adding ferments at the rate of, I think it's 1 quart per ton, a liter, 1 liter of ferment per ton of grain, decreasing the amount of grain consumed by the animals by 25%, and creating a gut flora, which is the foundation of immune system, where even though the bird flu is traveling all around, pigs are dying, chickens are dying, in other farmers' houses, buildings, they're not dying in these environments because the core microbiome is such that the biological terrain of those animals is not susceptible to the flu in the first place. So we've got opportunities and models at very low cost, using nature's systems to create a dynamic where we don't have bird flu as a concern. If we can understand bird flu is a message from nature saying these animals are not healthy and they should not be alive, then we can shift the way we manage the chickens in those houses. Instead of telling people that their traditional food ways of having chickens in their backyard, eating scraps, making high quality eggs and meat is illegal. So from my perspective, just because the government says I can't have chickens doesn't mean I shouldn't have chickens, right? In many cases, the government is responding to the demands of industry as opposed to doing what's right and honorable and true for the environment and human health. So yeah, there's a bit of a commentary on civil disobedience and strategy. The opportunities here, if we understand how nature works, to work systemically and holistically to actually increase the economic bottom line for the big animal producers, to increase the ecological systemic benefit for the environment, and improve human health can all be symbiotic. But just because the government says you can't do something, I don't think is a justification or rationale for not doing it. In many cases, somebody has to, as Thoreau did, go to jail to be an example where the media can say, talk about you, where you can use the opportunity to make noise to raise awareness. So that was Thoreau's point about civil disobedience. At some point, if things that are being done are wrong, somebody needs to be able to be willing to put their life on the line to stand up and say, no, I won't do this on principle, and not be afraid and embarrassed, but stand in confidence and say, if you need to lock me up, do it. But I'm going to use the court of law, I'm going to use freedom of speech, and I'm going to use this opportunity to raise awareness about something which is wrong in our culture and needs to be changed. So, in general, I would suggest that as something that should be considered. I have certainly experienced all over this continent the general assumption that because the government says I can't, therefore I can't. It doesn't seem to be questioned. It doesn't seem to be considered. It's just like, it's like sheep. And it's not quite like that in the States. There's a lot of things I have to criticize about the US, a lot of things I have to criticize about the US. But that's one thing I think we can offer you, is a little bit more chutzpah, if I can use the word. So anyway, that was a tangent on the topic of kelp. I did want to go back. I don't remember who I said it to. Right, exactly. I'm going back to it. I just wanted to go on a tangent because she said she wanted a tangent. And I said to somebody, I would talk about, I think I told him I should talk about the ferments. Because there's a really exciting opportunity here. There's a really exciting opportunity because if the beef is averaging 8-to-1, the chicken and the eggs are averaging 10 or 12-to-1, and the pork is averaging 20-to-1. If you're feeding your animals grain, their products are bad for you. Animals are not supposed to eat grain. We're not supposed to eat, I mean, the seed oils, people know about the seed oils and things, right? The 20-to-1, 30-to-1 of the canola oil and the soybean oil, right? This omega-3, omega-6 ratio is directly correlated to inflammation. Inflammation is directly correlated to chronic disease, right? French fries, if you fry them in canola oil with potatoes that were raised with all kinds of fungicides, are bad for you. French fries fried in lard or tallow from animals that had balanced diets from healthy potatoes are not bad for you. It's not the French fry, it's how it's raised and what it's made with. Right? The traditional way to make French fries was not with canola oil. Right? Lard and butter and things like this are what we have historically eaten for centuries. They're not inherently bad. If the animal is eating what the animal is not supposed to eat because of it's an industrialized system, then we can talk about the negative health effects 100%. So, yeah, I think there's an important topic, to discuss. We can go into it further if you want, or I can, go back to the topic of your garden.
About seaweeds
Yeah.
and salt, would not be a problem in the fields, the excess of salt?
Yeah. So I think I mentioned sea salt yesterday. I said rock dust and sea salt, basalt, granite, and sea salt are what I would suggest as the materials to use for remineralizing the global south, the desertified areas of the land that have been worn and weathered, that have not had glaciation for millennia, for millions of years. The laterite soils in Central Africa and India. Brazil, I talked about the soils in Brazil are laterite soils that don't have these minerals in them. I suggested 2 naturally occurring ingredients for populations that don't have sufficient money to buy fertilizer or specific rock minerals. I said rock dust, basalt, granite, and sea salt. I don't know if I gave you a recipe for sea salt or a quantity. I said, okay, I didn't. So it's 75 kilos per hectare per year. 75 kilos per hectare per year. If you are taking your Albrecht soil test and you see that the sodium level gets above 1.5% on your base saturation, then I can teach you how to remove the salt, the sodium chloride from your sea salt, and just get the trace elements. Because really we're looking for the trace elements, not the sodium chloride. Okay. So sea salt has 92 different elements in it. 92. All of the naturally occurring elements on the periodic table of elements are in sea salt in the ratio that is in amniotic fluid, right? Like the water you swim around in for the first 9 months of life, the amniotic fluid, right? That's that ratio. We're basically swimming in seawater. Interesting. And you know about sea turtles and, you know, things like that? If you ever kill a sea turtle, it could be like 100 years old, you cut it open and its liver is totally pink, right? It doesn't get purple and dark and yellow. Like fish in the ocean can live for 100 years or more and their bodies don't seem to age. It seems like it's something about that full spectrum of trace elements that they're swimming in that prevents aging. It's a really, really interesting thing. It's a tangent perhaps, at any rate. So sea salt and rock dust are nature's minerals that you can use to address mineral deficiency. So I said, I don't think I said either on the rock test, I said 2 to 20 tons per acre. So I think I said if you do a solid dose, you can do it once every 100 years. Right? You remineralize your land now at a significant quantity, and then your great-grandchildren can again check and maybe they need to do it again. This is a once in 2 or 3 generations application. That 20 tons per acre of rock dust, which I said you can usually get your hands on for 2 or 3 or 5 euros a ton. I said it'll cost more money to drive that truck full of rock dust across town than it costs to fill the truck with rock dust. 20 tons, a truck that holds 20 tons, each ton costs 5 euros. It's 100 euros to fill a 20-ton truck, right? It may sound like a lot of material. When you spread it out, it's really not much.
What kind of rock?
Basalt
Basalt.
or granite, I said. Basalt or granite very specifically, and sea salt at 75 kilos per hectare. If you do take a soil test, so there's a question about salt on the land. People have heard about the Carthaginians, the Romans and the Carthaginians. Carthage, you know where Carthage is? Yes. Carthage used to be, right? The Romans, you know about the Romans, where Rome is, right? Carthage was another big city that was around back then in the pre-Christ era. They were a seafaring, culture. They were well established. They were across the Mediterranean. They were, I think it's Tunisia is where Carthage was. And the Romans basically were conquering everywhere else, and they said, you know what? Even though you guys aren't trying to fight with us, we don't even want you around. And so they took them out. They sieged their city, and finally, when they got in, killed everybody, 100% slaughter, took down all their buildings, down to the foundations, threw them all in the ocean, and they put thousands of pounds of salt on their land, so that land would never grow food again. They got rid of the Carthaginians. So we have the story and culture of salt being bad for the land. Now I'll ask you, if you're making soup and you don't put any salt in the soup, how does it taste? A little bland? If you put too much salt in the soup, how does it taste? You can't eat it. If you put just the right amount of salt in the soup, what happens? All those flavors come together and it's like really, really good, right? So I said 75 kilos per hectare. I gave you a very specific number. Jerry Brunetti, this comes from Jerry Brunetti, per year.
Yeah, but how do you remove the sodium chloride?
We'll get there in a minute.
Okay.
You're like 3 steps ahead of everybody. Just give me a second. Just walking through really clear so people can take notes, say things 3 times so people hear it, right? You first tell people what you're going to tell them, then you tell them, and then you tell them what you told them.
Yeah.
Yeah, so you just bear with me.
We have lots of salt in Portugal, very high quality sea salt.
Brilliant.
It's the city where I come from, I can get that
For free.
like pure salt, unadulterated.
Yeah. Where I live, we can get it for $100 a ton. So 75 pounds per acre, 75 kilos per hectare, costs me about $4 per acre. And I always salt my land from stone wall to stone wall. I'm doing my entire property. I'm not doing the area just where I'm growing crops. I'm doing it for my entire property because I understand that that full spectrum of trace elements is profoundly valuable. It's at the core of the enzymes. Remember the enzymes yesterday? The enzymes that are the root of all these biochemical reactions, right? If you don't have cobalt, you don't have B12, you don't have molybdenum, you don't have the nitrogenase enzyme. There's, the lanthanide group, right? All those guys, those big ones down at the bottom, they do magical things. So I put salt on my entire property, everywhere. And now the goldenrod that used to be 2 feet tall, one of the weeds, is now 8 feet tall. Like the things that now happen on the property because I give those broad spectrum trace elements to the land are absolutely profound. Okay, so if you live in an area where it doesn't rain that much, which some of you might live in that area, and that salt will begin to build up, and too much salt is not a good thing. Too much salt, not a good thing. I said 1.5% is, if you're taking an Albrecht soil test, if it's above 1.5% on the base saturation, that's where you want to stop. 3% begins to be excessive. So you get up to 1.5, then you don't want to be adding sea salt. Maybe you do it every couple of years. Or you take out the sodium chloride because sea salt is about 96% sodium chloride and 4% trace elements. So what you really want is the trace elements. So how do you do that? You take a barrel. I suggest you go to the ocean, but I guess you can take salt and you can do it yourself in your backyard. If you have what would it be, like a 200-liter barrel, that size, right? That's we call it 55-gallon drum, we call it. And I don't know what the ratio of how much water to how much sea salt equals seawater, so I'll just use the example of going to the ocean. I'd say go to the ocean, take your barrel, stick it in the sand above the high tide line, and take a bucket and go down and get the seawater and fill your bucket up, and fill the barrel with seawater. Then you're going to need some lye. Lye, sodium hydroxide. How do you say lye? Or is it lye is? What is it? Yeah.
No, but sodium and potassium.
Either one. Lye. We call it lye. I don't know what you call it. LYE in English. We use it for, it's very caustic. Yeah. It's either sodium hydroxide or potassium hydroxide usually.
Can be both.
Yeah, it's both. Either one.
It can be either, right?
Yeah. So the way you make lye in the olden, so when I was a kid, when we were making soap, because we made our own soap, we would use the lard from the pigs. When we slaughtered the pigs, we'd cut the fat off and we'd boil it down, and we had lard. Lard? Everybody knows what lard is? Yeah. We'd have lard, so you could either cook with the lard or we would make soap. And the ingredients in soap are lard and lye.
Wood ash.
So you can make lye from wood ash. If you have wood ash and rainwater, if you let the rainwater run through the wood ash, you'll get lye. So literally, all these things come from natural materials. My point is, once you got your barrel full of seawater, you're going to be adding the lye, whether you buy it in the store or make your own, and you're going to stir it up. You're going to have it's got to be a plastic barrel because lye will digest metal, so don't have a metal barrel. And use a wooden stick. Getting there. So you're going to be keeping on adding the lye into the seawater, and you're going to be stirring it up with your stick, and you need a pH strip. And you're going to keep adding the lye into the seawater until the pH reaches 10.4. Once the pH in that water has reached 10.4, you have to let it sit for 24 hours. So you have to go camping. You've got to stay at the beach for a day. This is farm work, right? You're on farm work. You're not vacationing. It just looks like it. And then at the end of the 24 hours, if you look closely, you'll see that the cream, instead of rising to the top, has fallen to the bottom. You'll have a layer of milky fluid at the bottom of the barrel. That's your trace element concentrate. The clear fluid is your sodium, sodium chloride, just sodium chloride water. So you just gently dump the sodium chloride water back onto the sand. It'll go to the ocean. And when it comes down to the white fluid, you stop dumping. You put that in your little bucket that you used, and you've got trace element rich concentrate, which is complete rocket fuel. Absolute rocket fuel. This is one of the things I'd be putting in my irrigation line, my drip tape you guys have to get the conductivity up. That would be one of the amazing ingredients to be mixing in at a pint per the acre or quart per acre.
But in our scale, it's difficult to us keep the 20 barrels to the ocean and make the process. Can I also have a tank and use some sea salt, add water, and after add lime and
Yep, one of the guys we had speak at our conference this year, Erwin Westers, have anybody watched our conference? He's a Dutch farmer. He's a biodynamic organic seed producer. He's got about 100 hectares or 200 hectares. He lives right next to the dike. The dike, right in the Netherlands, like the ocean's here and his land is here, and there's a big wall in the middle. Like he lives right next to it, and he's got a manure spreader, one of those what do they call it? Slurry spreaders. It's a big tank on wheels. For farmers that spread that liquid manure on their fields. He's got one of those tanks, one of those. So he takes his tractor, he drives over the dike, he fills up the tank with seawater, he drives it back, he adds the sodium hydroxide into the water, lets it sit, pulls the trace element concentrate out, and then drives back over and dumps the seawater back into the ocean. So you can do it on whatever scale you want. The basic principle is 10.4, 24 hours. Good stuff's on the bottom, stuff you don't want's on top. The issue around here is, if you're going to be doing that on land, what do you do with all the sodium chloride water when you get done with it? Because you don't really want to dump that on your property. So I don't know what to tell you. All I'm telling you is the recipe. This is a product.
we can also acidify this water with citric acid, and we have not.
You're not acidifying it. You're alkalizing it.
You are neutralizing. You make the reverse process with citric acid, and we have the pH stable.
You still have a lot of sodium.
But it's still full of sodium chloride. Anyway, the point is trace elements. And so the real question I think we were talking about, well, it had to do with the algae. Right? That was what we started with? Was the algae in your, right.
Algae have all the elements, and probably something more.
So the question is, if you're concerned about the sea salt that would be on the algae, you could wash it, just leave it out in the rain, and the sea salt will come off. I wouldn't be concerned, personally. If you are concerned, there's a thing called the soil test, where you want to look and you want to see if the sodium level is above 1.5% on your Albrecht soil test. That'll tell you whether you have too much or not. In general, I would go and I would just get that kelp and I would lay it down and I would keep my soil covered around my plants. So keep trying to get back to your garden, but we have all these other exciting corollaries. Our hour and 45 minutes is going to disappear. Yeah.
These trace elements that you get at the bottom, then you spread across the land, or you put like a fertigation system?
Right. So this is an amazing material to use either in fertigation or in foliar sprays. Both. We'll talk a lot about that in the second half of the course, whenever that happens. I can give you just a couple pointers. One is that it's salt. It's has a very high conductivity. It can easily burn things. So whenever you have anything that's a salt, you want to buffer it with a stable carbon source. So there's two things that I generally recommend. One is humates and one is biochar. Biochar, people know what biochar is? Yeah, so that powdered, that sort of cinders that you'll find from a fire, or you can make biochar, that black carbon, if you crush it up into powder and add it to the water, that'll buffer the salt and keep it from burning your plants. Humates or leonardite, anyone know what leonardite is? That's a soft brown coal. It's an amazing, amazing material. Generally what I use personally is liquid humates, so I'll always mix humates in the recipe to keep it from having a burning effect. But yeah, you can put that down, I think, what would it be? 2 liters per hectare in a soil as a fertigation, or 1 liter per hectare as a foliar spray. That sea salt, that concentrate, is just an amazing, amazing product which you could use on a every week or every 10 days or every 2 weeks kind of regularity.
If you mix with the biochar, you don't put it in fertigation?
No, it has to be mixed with the powdered biochar or the liquid humates.
Okay.
Any of that has to be mixed, has to be ground to a powder.
Okay.
So basically you grind it to a powder, you put it in a bucket, add water, add the sea salt, and it'll stand as the water will become black. These are all things we should be doing outside. We could have a whole hands-on, like make this, here's what it looks like. Be much more practical than talking about it. Yes?
The ratio between water and trace elements, or is it important or not?
I'll say this when I talk about it in 3 months. When you're making a foliar spray, it doesn't hurt to say this 5 times. When you're making a foliar spray, anything that you're going to be spraying onto the foliage, the thing to be concerned about is it'll be too strong and it'll burn the leaves. When we were walking on the farm a couple days ago, it looked like something had been sprayed on the leaves of some of the perennials, and you could see this, all the plants at one point in time, all the leaves were brown. There was new growth that was green, but there was it sure looked like somebody had sprayed a foliar spray onto the leaves, which had burned the leaves. They all had this really kind of a burn look. So foliar sprays can be an amazing way to feed plants. They can also really, really be destructive to plants. So the basic ratio is 2%. So again, I don't know how to convert it. I guess you could convert it, but it's a 1/4 cup per gallon. That would be 20 milliliters per liter. Is that 2%? 20 milliliters per liter? There's 1,000 milliliters in a liter, right?
Yes.
Yeah, so it would be 20 milliliters per liter. So any kind of thing you're going to be putting in a foliar spray, you have, for every liter of water, you have 20 milliliters of the stuff you're using. If that's going to be in a foliar spray, and you always do a foliar spray, the rule of thumb is when the birds are singing. Birds are singing, which is either very early in the morning or at dusk. You have 2 times a day to spray things on the leaves. If you spray things on the leaves in the middle of the day, it's hot out, the water evaporates in about 35 seconds, and those salts will burn the leaf. My mother, I told her this year after year after year. I say, look, you can burn the leaf if you spray in the middle of the day. She says, but my staff doesn't come until 8 o'clock. Nature doesn't care when your staff comes. You spray the leaves at 8:30. It's a nice sunny day. Her blueberries are in complete shock. Her apple trees look like horrible because she religiously foliar sprays every week at 8:30 in the morning. Right? And those leaves look horrible. But she's a religious, has listened to the podcasts, buys all the foliar sprays, uses them every week. Foliar sprays are the way to salvation. So I'm not saying foliar sprays are bad. I'm saying all things in due time. And some things are good at certain times and bad at other times. All right. Can I get back to the garden? No.
One other thing, the biochar you put in this solution basically inside.
Yeah.
So with the
Right, so I would do the seawater and the biochar together.
Seawater and biochar are together.
Right, and that's what you mix at 20 milliliters per liter into the water.
Okay, great.
Yeah.
Thanks.
But yeah, you want that to be a dark color. You want, I mean, I use personally liquid humates. I think they're generally very inexpensive, and you can, humates or leonardite is a mined material. It's a brown soft coal. It's got a ridiculously large exchange capacity. It'll hold on to anything. It'll buffer anything. If anybody uses water to feed their plants that is from a city, from a town, that's got chlorine or fluorine in it, if anybody's starting seedlings in a greenhouse in trays and you're watering those trays with water from the city, and the city water has chlorine or fluorine in it, we've talked about this, you're basically giving your babies antibiotics every day. I told you about how important colostrum is. I told you about how important gut flora is. If you're watering your seedlings with city water that's got chlorine in it, you're giving your seedlings an antibiotic dose every day. You're killing their microbiome. So what you can do is you can add humates through a fertilizer injector into that water. So anytime that hose comes on, the chlorine and the fluorine are buffered with the humates. Understand all the dynamics of what's going on, understand the principle of how these things work, and you can use very inexpensive things to address these underlying struggles, which are constantly making things more difficult for your system, right? It's not natural for water to have chlorine in it. You don't think about it when you're watering your seedlings, but the net effect is actually quite detrimental. One more question.
Is it possible using the seaweed in mulching or not to recommend because it's
So somebody asked a question about salt and the seaweed, and that's what got us off of this complete tangent, which apparently has been a valuable tangent because I think we've covered a lot of things that we didn't cover before, which is why it's great to have time to actually go into these things. I'm really happy that we're doing this. Oh, this is only half the course, and we can do the other half later because all these pieces, there are all these pieces, and if I run full speed, this stuff doesn't all get covered, so this is really good. Personally, I'm not afraid of the salt. Personally, I love the salt. I think the kelp is a wonderful product also because of all the growth hormones and all the nutrients, and it's just a wonderful, wonderful thing. And if it's got some sea salt on it also, that's like added bonus. But it's possible you could get too much salt in your land. I told you how to test for it. And if that is a situation that's happening, all you have to do is lay the seaweed out and either spray it with a hose to get the salt off of it or to let the rain on it, and that'll wash the salt off of it.
Then the seaweed comes also with sand from the ocean. Will be a good for mineralization too?
Sand doesn't usually have much. It's what is it, aluminosilicate or something like that? It's usually a very stable, undigestible. It's not going to provide much minerals. No, generally.
But
you can have volcanic sand.
will not be a problem.
Not going to be a problem. No, it's going to be inert.
Can also improve our
If your soil's clayey, then that'll loosen up your clayey soil. Yeah. In general, okay, we're starting with some kelp. We're back to your garden. So, yeah, I mean, you have the ability to irrigate on your garden?
Drip irrigation.
Yep. And you get water from the city, from the town?
No, it's coming from them, which is like
Okay.
rainwater.
Perfect. Okay, that's good stuff. Yeah. Yeah, I don't know where we're starting in the season, but I definitely am in favor of the mineral balancing being done. So take the soil test and address the mineral deficiencies. If you've got time between now and when you're going to be planting your garden, getting cover crops established is a wonderful thing. So, you know, we haven't talked about rotations yet either. People know about rotations. You heard about rotations?
No, not yet.
You rotate your crops. People know, you know about the concept of rotating crops for certification. The rationale generally behind rotating your crops from an organic farming perspective is you want to break the disease cycle, right? You've heard about this? Like if you grow the squash here and you get the blight on the squash, then you want to move the squash because the blight is growing here, and then you want to keep the plants away from that blight. Or if the potato bugs are here with the potatoes, then you move the potatoes, and then that'll somehow keep the potato bugs from finding the potatoes over there. I know growing up on a farm that was certified organic, where we rotated with religiosity, that it didn't matter where we put the squash, the mildew would take them out. It didn't matter where we put the brassicas, the flea beetles would take them out. It didn't matter where we put the potatoes, the potato bugs would take them out. So from a practical standpoint, in my experience, rotating crops does not break the disease cycle. I think there's another argument which has something to do with some plants are heavy feeders and other plants are not heavy feeders. Has anybody heard that argument before?
Feeders.
Heavy feeders, that's what they say. As in, like, they take a lot of nutrients out of the soil, right? As I understand it, plants can, well, if you use fertilizer, and that basically causes the plant not to inject sugar into the soil to feed the soil life because it's getting the nutrients directly fed into it, the process of growing plants can be soil detrimental. But if you don't use fertilizer and plants are making sugar to feed soil life, which then feeds the plant, the process of growing plants is the thing which has built soil from subsoil, right? It's the act of growing plants which actually builds soil. So this concept that growing plants is destructive to the soil only occurs when we're engaging in practices that are not harmonious with nature. So in my mind, I think I've said this before, every plant has its own gut flora. So an onion has a certain gut flora, and a potato has a different gut flora, and a corn has a different kind of gut flora. And I use the example of the colostrum, and I would say it wouldn't make sense to give a baby rabbit colostrum from a cow. It wouldn't make sense to give a kitten colostrum from a dog. It doesn't make sense to put an onion in soil where potatoes grew last year. If a tomato has a different gut flora from a broccoli, why would you want to put broccoli where the soil is all set up for tomatoes to grow? So
that increase diversity and then increase the soil microbiome health.
Well, the assumption is in this whole model monoculture. The assumption is that you have only tomatoes growing here and only potatoes growing here and only cucumbers growing there. And that is part of the practice that is not in harmony with nature and how nature grows things. So I try to do polycultures in my growing areas. We'll have tomatoes here and squash there and beans there and things like that. We haven't talked about spacing yet, but we'll talk about spacing. I'll talk about my kale plants. I put my kale plants 1 meter apart because a kale plant wants to be a big plant. And then between when you put that kale plant in the ground and when it gets big enough, you can have carrots and beets and radishes growing in that space. So depending on the scale of your operation, polycultures, where you can basically be using that space to produce multiple crops in the same area is a way to get that diversity occurring. As well, I think I talked yesterday about weeds, what we call weeds, as nature's cover crops. And nature actually knows what she's planting and why she's planting it. And so if there is clover and dandelion and pigweed growing underneath your tomato plant, I would call that biodiversity. And I would not pull those things out because they're not going to compete with my tomato plant. So anything and everything we can do to maintain and establish biodiversity is good. Yes.
This is the intercropping?
Intercropping, yes, precisely, is I think better than monocultures. But from a strategic standpoint, I put my kale back this year where it was last year. I put my tomatoes back this year where they were last year. If my arugula seeds that I've let grow and go to seed fall on the ground, then I rake that bed and water it, and those arugula seeds germinate there, and I didn't have to buy seed, and they grow with great vigor because that's where their mothers grew, and that microbiome was established well there. So the point was about cover crops and diversity, and so if you can establish cover crops in your garden area between now and when you're planting your crops, I think that's a wonderful thing to do, and it's a great way to establish good living roots, to get that broad diversity of microbiome. And then the question is, how are you going to kill those cover crops between, when it's time to plant? So, do you want to give me any more specifics about your garden area so I can tell you other suggestions about things you could be doing?
Let's say in the bigger scale, it's like drilling crop as well, like carrots, onions,
Mm-hmm.
and there are some transplanting crops like cabbages, depends, this is more during the winter, and after squashes or melons, it's kind of diverse system.
Mm-hmm. Yeah, I mean, I guess it depends on how you're harvesting and how you're managing.
Because this is the bulk scales. In the garden, normally you use a lot of hands and everything is handmade. But after, if you really want to do it on a bigger scale, you engage mechanization.
Mm-hmm.
So how this can go together?
I feel like I need a specific example of a specific thing to be able to give you a specific answer.
Carrots.
Let's say carrots.
The experience which I have usually when I did bad job and the bed was not well done, like fine, and I made bed drilling. So the seed went to different deep of the soil, or they were not sufficient cover because there was the mulches that after they didn't really cover the seeds. So we had bad germination, bad stand crop. I'm speaking now in a big scale where we use the tractor to make the bed and we drill by the seeder. So, and when we have bed establishment, of course, we after see more weeds coming because it's not covered all the bed.
Yeah.
And of course the productivity goes down, and we are speaking about conventional land. And now this farmer want to go regenerative. So imagine carrot operation. So how that carrot operation could be more regenerative, because when we are harvesting, we use machinery. We go and we go below the carrots and we pull it out, so everything is apart. The machinery runs everywhere on the field because they are not able to keep in the way where the tractor goes. Big machineries, they don't have stability to keep there. So, and you need to start the process again. You make the beds again to drill other crops. So this is like potatoes is the same.
All the crops that are
In the ground.
Yes.
Yeah.
For tomatoes, I think it's a bit easier because we can transplant tomatoes, we can establish the bed, and we need to move them really.
For processing tomatoes, he's saying, if you're working on a big scale farm, and these are going into a tomato sauce in a factory, and everything's being done by tractor, right? Or beans, or all kinds of things are the.
We don't harvest the superior part. We don't eat onions or carrots. We need to take out the land.
Either way.
You can change the harvesting machine, because in the carrots you can harvest with the.
We do, but anyway, to pull out the carrot from the soil, you need to go under the carrots. Yeah,
Which is, I mean, this goes back to the there's this story about thou shalt not disturb thine soil, or thou art a sinner, right? Like this, if you till, you're a bad person. If you use chemicals, you're a bad person. There's like all things in moderation. Okay, so you're growing potatoes, and there is a soil disturbance process, which is part of that. There are 50 different things you can do to help build soil health, and you have that one time when you're going through and you're disturbing the soil. That's not the end of the world. It's really not the end of the world, right? I mean, all things we're growing annuals. Until we stop growing annuals, this is going to be part of the process. So what are all the things you can integrate into that process? Again, we had Erwin, who is one of the speakers at our conference who grows a lot of potatoes in the Netherlands, and he had a video of how he grows his potatoes, and he has some areas where he's growing his cover crops, and he cuts them and turns them into mulch, and actually round bales, and he's got a bale chopper, and so after the potatoes get planted, he comes through and chops that hay into small particles and sprays it out over the land, and so he's got a mulch layer over the land that the potatoes grow out of, and that dramatically, it keeps the soil covered, it keeps the soil fed. You can be doing that with carrots. There's all kinds of ways of, still operating on scale, integrating these techniques and principles. If we stop producing food on scale, most people are not going to be able to eat. So you start where you are, and you identify things you can do better. If you can inoculate to establish good gut flora, that's amazing. Great, it doesn't cost hardly anything, and it's totally beneficial. If you can address mineral deficiencies, so you have sufficient, molybdenum, then you don't need to add nitrogen fertilizer. That's going to be very powerfully beneficial. If you add cobalt, so then you got vitamin B12, you're going to have a much broader spectrum of microbes. Like there's all these, you can do foliar sprays that can supplement with nutrients. There's all kinds of wonderful things you can do to take how things are done and do them better. And so, in my mind, perfection is not what we're aiming at. We're aiming to do, remember the curves, right? The peak of the curve is over here in the 20th percentile. If we go from 20 to 30, that's a massive improvement. So, each of us needs to be realistic about our own context. And I said, if you've got a budget that's 100 euros per hectare for fertility, the question is, which things are you going to be removing and which things are going to be supplementing? Like you just change that slowly. So, yeah, I think if you know there's some simple things you can do those. Don't get ahead of yourself and think about step 5, 6, 7, and 8 until you've done step 1, 2, and 3. I think one of the biggest problems people have is they get ahead of themselves. Like, you are where you are right now. The problems of 3 years from now, you'll have answers for 3 years from now. You're not at 3 years from now right now. Where you are is where you are right now. So you worry about the things you can do right now, and once you've done that, nature will show you the next thing, and you do that thing next. As soon as you start worrying about the whole world, you start worrying about how everything's horrible, these people over here, things are suffering, that's not possible. As soon as you get out of your own mind, and you start thinking about stuff that you don't have any control over, you're separating yourself from reality. Like you're dealing with a projection of something, and it's like the election, right? People keep asking me about the American election. Like, I've got no control over the American election. Like, it's completely irrelevant. I literally don't think about it at all until somebody asks me about it. And I'm like, not thinking about it. Doesn't really matter anyway. They're Tweedledee and Tweedledum. But I can't do anything about it. I can put my attention on what I can do. And then I put my attention on the next thing I can do. And then I put my attention on the next thing I can do. And if we each focus on what we can do right now, my experience is life, nature, God, call it what you will, shows us our next step next. And that's how it works. So, yeah, I'm sorry. That was a good opportunity to go on this rant that I like to go on. No, because it's really easy to get worried about all this stuff. You're like, oh my God, what about this? What about this? And we had this conversation with Andre. Was it yesterday, the day before? We were having this exact conversation. Yeah.
So see, it's a very interesting conversation.
Well, no, it's mental masturbation. It's not your business. I use the metaphor of the Amazon, right? I use the metaphor of the Amazon. I say, you're in a boat, and you're going down the Amazon. There's lots of trees on both sides. You have no idea around this corner what's going on. There could be headhunters. There could be rapids. The future is not what you can see. If there's an eagle flying above you that can see everything that's happening, that's not your perspective. It's not your business. to worry about what's around the corner because you aren't there yet. The only thing you can do is be right here, right now, and deal with your reality right now. Like, even if you worried about it, you still couldn't do anything about it. Might as well be present with where you are. So it's a real, it's a I don't know what it is. I think it's like how we use our mind, how we use our attention is one of the most powerful things we have control over. And when we put our minds onto things that we don't have control over, then we're taking away our power to do the things we can do. So it's I don't know if it's a spiritual practice or what it is exactly, but staying focused on where you are and what you can do and not worrying about things you can't worry about. I truly believe there's a greater order in the universe. And all these things are happening where the problems are going to be solved because it's being taken care of by somebody I can't see in ways I don't know. I mean, we had this conversation with you too. Yeah. It was you. Maybe it wasn't Andre. Maybe it was you. I don't know. I think we had this conversation also. Yeah. Like, I don't know. People believe there's a greater power. Some people do. Some people don't. Maybe. Sort of. If there is, it's worrying about its business. It's our business to worry about our business. That's how I see it. Okay. Can we change to a new topic? Seeds?
I would like to know one thing about rock tests.
Yeah.
How do you decide between basalts and granites?
How could you or how do I?
How do
You were in Italy yesterday at this farm, Matteo.
Not yesterday.
No, you were. Sorry. Sorry. You were at Matteo's farm yesterday.
Yes.
Yeah. So Matteo Mazzoli, he's in northern Italy, is probably the person I've met who has done the best job of how this should be done. And what you should do is you should systemically go to all of these different quarries that are out there and get samples and run them through a lab and see what the total extraction says is present in that rock. I'm pretty sure he's done this in Italy for like 40 different quarries. And as a consultant, when people send him their soil test, he looks at what's in their soil and what's not in their soil, and he says, looks like this rock dust over here is the one that would be best for you. And that one, or maybe 2 tons per acre of that and 5 tons per acre of that would be your systemic benefit. So theoretically, that would be the right thing to do. We used to have this campaign at the BFA when we were just working in North America, and we were trying to get people to engage in this process, and we'd had this whole thing, we're like, if you could just, together, all of you, in your bioregion, identify the 10 quarries and work together to get them collected, samples collected and sent to the lab, for everybody in your whole bioregion, you could identify which rock dust would be best for everybody in your soil type. And you could all do it together, and you could empower everyone in your community. And we had yet to find one group actually take it on. So, yeah, I think the opportunities are massive. And especially when you start to look at the developing world where we don't have resources, maybe they'll get better uptake in Kenya. But yeah, theoretically that would be the strategy, is you overlay your, usually if you go to the local university, they'll have a geological map and they'll tell you, which rock types are present where in the landscape. And then you have, oftentimes the government will have a list of which quarries have been permitted. And so you can see where the quarries are. So if you look at which quarries, you can figure it out. You can figure out 90% of the work online ahead of time by looking at your geological map overlaid against your quarry map. And then you ignore the ones that are in limestone soils or whatever else, and you just look for the granites and the basalts. Go get the samples, yeah, and then match. So what I do, I just get something that's local and cheap and spread it. So
That's very good basalt in Portugal.
there's very good basalt in Portugal, almost for free.
I use it for more than 10 years.
Talk to this guy about where sources might be. Yeah.
Very, very fine, very nice.
And salt as well. We put salt in
Mm-hmm.
Just another question for inoculation.
Yeah.
To big scale I understood the method.
Yeah.
Can we do, from the same quantity, can you put more water, it's less concentrated?
Yes.
When there's a scale that we can work towards?
I don't know the honest answer. Experiment. Yeah. Okay. Can we talk about seed? All right.
Quality.
And what to do with it? All right. So this is one of the other major topics I've got for the course is seed quality. I think I mentioned it earlier. How much time do we have? We got half an hour till lunch? Okay. Yeah. Okay. This is a really big one. I think I've referred to this obliquely a few different times. I've talked about the health of the mother and the health of the baby. So let's just talk about the logistics of getting seed for starters. Most people are buying seed, which indigenous cultures, like that would be sacrilege, right? I mean, we've got Monet and Picasso and I don't know, who's other famous artists? What? Michelangelo, yeah. Da Vinci, yeah. Right, as I understand it, like the cultural wealth of traditional cultures was, you know, seed was very, very high in their like overall estimation of the things that were most important. Sacred thing, seed. And we've commoditized it. We've considered it all to be relatively uniform and just something you can purchase. So let's just talk about this. I've done some decent research on this. Let's use a couple examples. I was talking to a guy who, John Navazio, who did a lot of work in seed as a seedsman for 30 years. Finally, in the end of his career, worked at Johnny's. I think he published a book actually about seed. But I was talking to him about this, and he said, we'll use the example of Thai spinach. There's two growers on the planet that grow Thai spinach. They're both in Oregon, and when they harvest the seed, they send it to the seed company. The seed company takes that seed and puts it through a series of what's called screens. So a screen with different size holes, and the seed that's too big to fit through the 12 screen goes back to those seed growers to plant for next year. The seed that then is too big to fit through the 10 screen goes to all of the spinach growers in the Salinas Valley in Central California that plant spinach at 50 acres per planting. Then the seed that's too big to go through the 8 screen goes to big farmers, maybe in New York State, that buy seed at 50 pounds at a time. And then the seed that is too big to go through the 6 screen that will still germinate gets sent to the packet trade. And the packet trade is every seed company you've ever seen that sells packets of seed. There's a direct connection between seed size and seed weight and seed vigor and seed vitality. And what you're offered when you buy seed in the seed catalog is germination %. You're not offered germination time. Has anybody ever taken a handful of tomato seeds and looked and seen fat seeds and flat seeds? If you take the fat seeds and you plant them in this tray over here, and you take the flat seeds and plant them in this tray over here, you'll notice that these ones germinate between day 5 and 7, and these ones germinate between day 12 and 14. Anybody ever notice that? Tomatoes, some germinate early, some germinate late. If you kept those tomatoes separate, if you planted these tomatoes that germinated early in this row and these ones that germinated late in this row, you would see that these ones grew with greater vigor, had better yields, had better pest and disease resistance, and these ones would grow less rapidly, be more likely to succumb to infestation, etc. So effectively, when you're buying seed, the industry is already selecting out the good stuff for people who know better. Because you're ignorant, you're a sucker, and they're happy to take advantage of that fact. So there's a couple things you can do when it comes to ordering seed. There's 2 things you can ask for. One is either test weight, and the other one is seed size. So I'll give an example. If I'm ordering arugula seed, I'll call up Johnny's and I say, I'm looking for some Astro arugula, and I'll say, how many seeds per pound do you have in the batch you've got? And that's something they'll have in their computer. If you do what we used to do in the olden days, which was you get a hard copy catalog, you'd open the catalog, you'd look what you look for, and then you'd call the seed company and order the seed, Does anybody do that anymore? Or does it all happen totally online? Well, if you do it online, you don't get to talk to the person and ask these questions. But if you do go do it and talk to the person, they'll have a customer service agent, and if you say, what's the seed size on this batch of Astra arugula you've got, and they'll go click, 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 200,000 seeds per pound. You say, thank you very much, and you hang up. And then you call Hi Mowing, and you say, Hi Mowing, I'm looking for Astra arugula. Can you tell me the seed size on the batch you're currently selling? Click, 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 250,000 seeds per pound. And then you hang up, say, thank you very much, hang up. And then you call Fedco. You say, Fedco, looking for Astra arugula, click, 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 150,000 seeds per pound. Anybody want to guess which one I order? 150. The fewest seeds per pound correlates with the biggest, most vigorous and vibrant seeds. So I remember talking to Johnny's one day. Johnny's is a seed company we have that's based in Maine. And I was asking them, I was talking to them about this, and they said, sometimes we get bolero carrots that are 80,000 seeds per pound, and sometimes we get bolero carrots that are 800,000 seeds per pound. And I was like, oh, really? Like, yeah, but they all germinate at 84%. Like, but these little guys, they got no vigor, right? So anybody ever saved seed? Like you plant a half a packet of arugula, or maybe Swiss chard. Ever like Swiss chard is obvious because they got those big, those big seeds. But like maybe what's another one? Dill. If you ever planted dill, and you get these little dill seeds and you plant them, and you grow the plant and you let it go to seed, and you take the seeds and you they're like 3 times bigger than the one. Anybody ever seen this? Ever done this?
Yes.
The stuff you get is the runts of the litter. Right? The stuff you get is the runts. If you're buying this stuff, 50% of your yield potential is lost immediately. All the rest of the stuff you're doing, you're starting off with the runts. Everything else you can do, you can take control of. You have ability to, like I said, you can shift the microbiome, you can shift the mineral balancing, you can do the cover cropping, you can mulch, you can maintain hydration, you can do all kinds of wonderful things in short order. You can totally dial things in quickly if you've got the attention and you're focused. But seed quality, we've got generations of unhealthy mothers, right? Fed fertilizer, sprayed with chemicals for how many generations in the lineage of this seed that you're purchasing? If you understand epigenetics, if the principles roughly make sense to you, understand this is a massive piece of the puzzle that no one's ever told you about, because anybody who's busy selling you things, these things, has no reason for you to know. So what I tell people wherever I go is, if there's 20 people in this room, and there's 5 seed companies that you all generally roughly buy from, and you were to go through the process, which is very uncomfortable, of asking these companies, like, make your list of all the seeds you want, call them up, go through variety by variety, crop by crop, ask them for each one, what's the test weight or what's the seed size? You write it down, ask them the next one. Write it down, 50 seeds in, you say thank you very much, and you hang up. Then you call the next company and do the same thing. If you do that through 3 companies or 5 companies, and it'll be very emotionally uncomfortable, I've tried it. That person on the other end of the line is politely answering your question once, which no one ever asks, but they're expecting you to order it as soon as they answer the question. But if you proceed forward, crop by crop, variety by variety, and you ask all these questions and then you hang up without ordering anything. I've talked to seed companies, and what they've told me is, yeah, we know about this, and we're not going to do anything until people ask us for the good stuff. At which point they could very easily order the 10 screen instead of the 6 screen. It might cost them, I don't know, an extra 15%. I was working with John Kemp on this. So we've been talking about this for years. He was working with a tomato grower Tomato grower said, tomato seed grower, I grow tomato seed for a contract. John gave him a recipe for optimizing seed quality, totally dialed it in. The guy grew these amazing tomato seeds, sent them to the company of the contract with, and they got sent back. They were too big. Right? The economics didn't work. They want to be able to provide 25 seeds per packet and have them only cost a certain amount so they can get their margins. It's an economics thing. Right? It's completely perverse, and either we take responsibility for saving our seed or just letting our plants go to seed and drop their seed like they used to do in the olden days and let that seed germinate, which we'll talk about in a little bit after we talk about early childhood development. And there's a few people here that were almost in tears a couple days ago when we were walking through. And when you understand how profoundly you abuse your children in the process of starting them early in your little cell trays, you'll be in tears also. Like the things that we do to our children as opposed to letting them germinate in the ground and grow, when it all comes back all the way around, it's actually a lot easier to do a lot less and a lot better for everybody involved. Not just your back and your effort and your labor bill, but your economics. Yeah.
This is valid also for the hybrid varieties.
So hybrid varieties, yes, this is true. The seed size, absolutely. Actually, Thai is a hybrid variety. That was using an example for. There's a really important conversation about the difference between a hybrid and an open pollinated or an heirloom variety. In most cases, the hybrids have been selected to be very uniform, to perform well under a fertilizer protocol, a soluble nutrient protocol. In general, their roots are much smaller, right? The ability to establish symbiotic relationships with the soil microbes to access nutrients from the land has been bred out of the hybrid varieties. They have been selected for uniformity, for thick skins, for shipping. The open pollinated, the heirloom varieties were selected for flavor. They were selected for nutrition. They were selected to do well in the land before fertilizer got invented. In many cases, those heirloom varieties have not been well kept over the past number of generations. The people who were saving the seed were not doing a good job, and so you can buy some of those heirloom seeds and they're very small, they're very weak, but they have the inherent capacity that if you were to grow them out in good soils for 2 generations, they'd be much more vigorous and productive. So on my farm, I can think of maybe 1 or 2 varieties of plants that I plant that are hybrid, but I only plant heirlooms, and I always focus on open pollinated. I always focus when I'm reading a seed catalog. I mean, anybody else love reading seed catalogs? Oh my God. Talk about, I have my purple row, and I got my black row, and my yellow row, and my orange row, and my white row, and my striped row, and each row has at least 5 or 8 varieties in it. Oh, tomatoes are just such amazing things. Anyway, 100%. Yeah, for me, the diversity of the color and the shape is the beauty. Oh, the carrots, the beets, everything. You want
Everything.
I don't want uniformity. I want a mix of colors. Every bunch of carrots, every bunch of beets, every tray of tomatoes. A tray of tomatoes, I used to sell a lot of tomatoes. 15 pounds, what's that, 7, 8 kilo tray. No 2 tomatoes of the same variety.
Yes.
Everyone's different colors. Sorry, was that your hand up back there?
So if we were to large scale with plants like cocoa crops across hundreds of hectares
Yeah.
with different clients,
Yeah.
support,
Yeah.
we're not saving seeds it's not really working as a logistics. Okay?
Mm-hmm.
Things that we can improve to improve that seed process then. One, of course, calling the same companies and working out where can we have better providers. I was also very interested in the conference, in the conversation you had with John Kemp about this mineral, I don't know if
Yes.
inoculants,
Mm-hmm.
but also to add that to the seeds. So I would
Yeah.
say like the inoculants that you mentioned, which are microbes, but
Yeah.
also the mineral inoculants, do you think like they could work in combination? Should we try to do both, or how?
Right. So I said that there's a lot of things that you can't do except over multiple generations to bring the vitality back into the seed. And John has put together a product, I think based on Albrecht's work, where he's basically taken some soluble nutrients like copper sulfate and zinc sulfate and sodium malobate, those salts that I would be the things you'd recommend to address mineral deficiencies. I'm pretty sure he's mixed them with liquid humates and has this uber trace element concentrate that he recommends you dump onto your seed before you plant it. And it will, basically sucks some of those elements into the seed and gives them much greater vigor. So that is a thing you totally can do. I'm not quite sure what the recipe is and how to make it, so, but yes.
Always doing that.
You guys said you're trying to reverse engineer it. You're reverse engineering it. Yeah, so there are some things you can do like that, which I would think absolutely go play around with. I haven't done it myself enough to be able to say, to give you specific suggestions and know I can feel comfortable that you won't have bad things happen. But I know John's been working on that. It's been a really important piece of the puzzle.
We can try that. We can try that.
Well, these guys here, it seem like they're maybe thinking about trying to facilitate access to a lot of this stuff that we've got in the US, which you don't have here in Europe, which I don't know the politics of who's doing what, where, in which country, but when I go on and give these courses and people don't have access to soil tests and inoculants and stuff, I'm like, God, wouldn't it be nice if you guys had access to some of this stuff? There's this guy, I told you about him yesterday, David Knaus, who's got these micronized minerals that are like down to 1 micron, and literally 2 kilos per hectare of some of these micronized rocks, which cost like $3 a kilo, like $2 a kilo. It's stupidly inexpensive. And if you get the right soil test and you get these right micronized minerals on, like things like magic happens. Like we really have the tools and the products developed to really powerfully, positively impact soil function. But the logistics now are an issue. How do you get them across continents? How do you get them imported? How can we do manufacture in this continent, et cetera? That's some of the stuff that I'm hoping to help support with behind the scenes. Because
we are ready to, the only thing we don't know how to do yet here in Vivid is the micronization to 5 microns or 2.
Or 1.
The process, the industrial process. Apparently we heard about the
We'll work on it. Yeah.
But you told us also about it's dangerous to be handling these products without being
Without masks and stuff.
So
We'll talk about these things behind the scenes, but anybody who wants to be part of this conversation, the more we can support you guys and having access to these products. I mean, the chemical industry has been developing for billions of dollars of development over decades, products, and this biological community is like back to rock dust and sea salt. Like we don't have this stuff dialed in. And if we did have it, like for you, like I want, as a farmer on scale, like, okay, I'm just gonna mix this in with my planter, like the chemical farmers have, and you could get the results that would blow them out of the water. I mean, we're running with like, fighting with one arm behind our back, right? So these are logistics that are available on the planet, just not available here in Europe. And the more we can support that, I mean, for me, it's not just Europe, it's Africa, it's Australia. Like, let's get the supply chain lined up with this stuff around the planet. If we really want to get the transition to occur, if we can get the products that have been developed available to support the results, that's going to be one of the fastest ways to make this all happen. But yeah, I think your initial question was about harvesting the cover crop seed. And in the olden days, we did have seed combines that would be able to take in multiple types of seeds, and then you could sort them later. So there's a whole other conversation there, I guess, about cover crop seed and growing polycultures and harvesting them.
You need to integrate within the management that is already there. So like harvesting the seeds and collecting the seeds is not really something that the farm managers are willing or interested. It's just add another layer of complexity. So
But if the seeds fall on the ground and they germinate next year, then you just need to plant them once and they'll cycle themselves through and become more endemic. I mean, that's what we're trying to do, right? We're trying to do things once or just a couple of times and then not have to do it again. With all these systems, we're trying to address the deficiencies that are present. It'll take a little bit of work to get over that hump, but then you shouldn't need to keep putting things on if you're playing it long term. Yeah. Okay, 15 minutes left. Shall we talk about early childhood development? Spacing and timing. I think this is a really important topic, and I usually save it for the second half of the course, but I expect that some of you will be starting seeds between now and, say, March or whenever we get together. Yes?
Because we were talking about seeds, quality, maybe collecting our own seed.
Yeah.
Where do you keep the seed?
Personally, in a freezer. I just collect them all, put them in a Ziploc bag, write whatever they are or don't, right?
In the bag?
Yep, and I,
To the freezer, so -0 freezer.
yeah. Yeah, where I keep my meat and fruit and stuff like that. Yeah. Generally, I think degradation occurs slower at lower temperatures. Yeah. Yeah. Okay, so I'm going to use onions as an example here. And again, I don't know what your climate's like and when do people start onions and transplant onions? Onions. Cebolo.
Right now,
Cebolla.
we see right now, and maybe, but the mainly season is about March, February, March. Depends on the region of Portugal.
Okay, so
The onion, not the short daily onion or long
Short
daily
or
onion.
medium or long day.
we only have one onion
You
season.
only have one onion, yeah.
We put our onions in the spring and then we harvest them in the summer.
We
And then the rest of them, there's only one onion season where I
can
live.
plant now.
You can plant now.
Yeah.
I know there's onion seedlings in this.
Yeah,
They guys have onion seedlings. So I'm just going to use the example of a cell tray. Everybody know what a cell tray is? Those trays with all the little,
Yes.
like a 96 or a 128 plug tray.
Yeah.
So I'm going to call this, what we'll call it 1 cubic centimeter or something like that. So we'll say this is October 15th. Okay, so October 17th, a little bit of root comes down. October 19th, a little bit of green comes up. October 21st, a little more root comes down. 23rd, a little more green. 25th, more roots. 27th, more green. 29th, okay. That's 2 weeks. How long do you usually keep your onion seedlings in the plug tray before transplanting them out into the field?
Normally, usually, I don't do, I'm not doing it, but normally I think in large scale we see directly in the
You seed directly?
Yes.
Okay, well that would be a good thing to do. I was looking at plug trays in here where, I mean, is anybody else here? Or we can do squash, or we can do tomatoes, we can do any crop you want. Tomatoes. Squash, what do you want to do?
Tomatoes,
Kale.
squash, broccoli,
Peppers.
peppers.
Okay. What's that?
No, you were asking how many times did we keep it in?
How long do you keep them in the trays?
Sometimes it depends. If it rains, then we cannot. Sometimes it more time than we expect.
Yeah.
But at minimum 3 weeks.
Minimum 3 weeks, sometimes 4, sometimes 5 weeks. Let's just say 4. All right. Okay, so again, your climate's a little bit different than mine, so the examples I'm used to may not be applicable. We have this thing we call
I can show general
pigweed.
recommendations if you want. Farm,
I think this is sufficient for the time being, the concept. Yeah, I'll make my point without,
okay.
I think without that, but it's, yeah, so pigweed, amaranth is a weed we've got that grows, I think we talked about that red root amaranth. Where I live, it will germinate oftentimes in the field sometime in the end of May. And if it does germinate in the end of May and no one touches it, it will grow into this big, beautiful, 5 foot, 6 foot tall, 4 foot wide, beautiful plant full of these little prickly seed heads. Yeah, you know what I'm talking about, that one, amaranth? But if it germinates in the end of August, and we have frost that comes in, now it comes in October, it will go about 6 inches tall, and then it'll make out as little seed heads. Has anybody ever seen that? Ever seen that variation in growth habit of a plant? So the first question is, well, those different varieties of pigweed? No. The thing that was different was when it germinated. And so, as I understand it, when it's germinating in the early summer, late spring, it says, okay, we've got long days, we got short nights, you know, warmth. I got 3 months to rock it. It looks back into its 50,000 generations of, you know, genetic memory and says, in these environmental conditions, I can go for it. And so it builds a body that's got the capacity to, you know, produce 500,000 seeds. When it germinates in the end of August, it says, short days, cold nights, frost is coming soon. I better hurry up and squeeze out some seeds before I get killed by the frost. And so it gets 6 inches tall, it sets up some seed, and successfully dries that seed before the frost comes. Bam. Off to the next generation. I think it was John who told me this. I don't remember who. Said that corn will, on day 7, determine how many ears it will make. On day 14, will determine how many rows will be on each ear. And then on day 21, how many kernels will be on each row. So plants can't move around like we can, and like, we don't like this environment, I'm going to go somewhere else. They're like stuck where they germinated, or until God invented transplanting, they were stuck where they germinated. We can talk about fruit trees later, but yeah, they basically read the environment, determine what the dynamics are from their genetic memory to optimize productivity, and then build their bodies accordingly. So if we're starting with these plug trays, we call them cell trays in the US, which I think is maybe even a better word for it. What happens is, you know, I was using this onion as an example because where I live, people oftentimes will start their onions by February 1st or February 15th and not put them out into the garden until April because we want to get a start on the season. We want to get ahead. So if at 2 weeks this onion has read the environment and determined that it's got 1 cubic centimeter of soil to build its bulb out of, even though it may have genetically had the potential to have a ½ kilo bulb, it'll begin defining downward every day thereafter the size of that bulb based on the fact that it doesn't have any more, that is the sum total of soil it has to work with. So this is a very, very powerful thing. I call it, you know, child abuse. I would use the metaphor, actually there's a story I know of a woman who actually wrote a book. I heard it on the radio a long time ago. She had adopted a child from post-Soviet Russia in the mid-90s. He had been born just after the collapse of the Soviet Union. He was given up and raised in an orphanage. He was basically kept with a lot of the other kids in the orphanage, which was poorly funded and so understaffed, in their cribs. They got their diapers changed and they got fed, but they were kept in their cribs basically 24 hours a day. And so when she was, and her husband adopted him at 5 years old, he'd never been out of a crib. The book was about his psychological and emotional difficulties because of the fact that his early childhood development experience had been so profoundly limited. And you know, when he was a teenager and they were in the grocery store and he wanted something and she said no, he dropped his pants and pooped right on the floor. You know, his social skills didn't exist. There was another example of when something had happened and he got angry and he'd literally broken her arm because his emotional sensitivity, his ability to like be acclimated to what would be considered acceptable was not there because of the experience that he had not had when he was young. And so Yeah, I liken the way that we treat our seedlings in these plug trays to that. As I understand it, we profoundly limit the function and the capacity of our seedlings, of our plants, with the things we do early in their life cycle, because of what we're taught, because of what we're sold, because of what everyone else tells us. You know, the potting soil, the media that you put in these cell trays. I like to use the example of, you know, what would you want to feed your children between birth and kindergarten? Would a nice diet of, you know, grilled cheese every day be the best way for them to have strong bones and good immunity and health? Or would you like to have a more balanced diet? Because if you just have peat moss and cocoa coir and NPK, you're not actually creating a dynamic where those plants are able to build strong bones and good immune systems. And that first early development stage of the plant's life cycle is profoundly destructive. So there's a technique, there's a one of the most inspiring, I think, global grassroots farmers movements that I've heard of, that I think is one of those ones that almost no one has heard of, which primarily is because there's no selling of anything involved. It's called SRI. Started off in Madagascar, and since has evolved to be referred to as SCI. Literally, it's, you know, I'm not sure if it's tens of millions or hundreds of millions of small farmers. I like to say from Morocco to Malaysia, just, you know, across that whole swath of the planet, where we've got a lot of smallholders that are subsistence farmers. I understand the literature from India shows that it's foundational in reversing misogyny, like profoundly shifting the male-female, you know, power dynamics in villages and empowering women. It's a completely profound, empowering set of principles, and it's so simple and apparently yet so counterintuitive that a lot of people perhaps have not been exposed to it. But I'd like to just sort of run through the basic outline of it here, and then, yeah, invite you to experiment sometime in the next growing season with these principles. It's, I think, extremely, extremely empowering. Although I see that it's 1 o'clock right now. So I think, can I save this for after lunch? You're sufficiently inspired? All right. I feel like I'm done talking for a little bit, but yeah, all right. Reconvene at 2? Yeah, 2:30? I'm not sure what the schedule says. 2:30. Yeah.